sustainable charging technologies for the electric vehicle. And the today's center is at Satyabama, and it is the day 4 on 11th May 2022. The session is going to be from 9 a.m. to 12 p.m. in Zoom platform. And the title for today's session is the Academic and Industry Conclave on Green Sustainability. And we have 4 speakers today here. First is Dr. E. Annadevi, followed by Dr. D. Prabhu, that is followed by Dr. S. Satish, and he is followed by Dr. D. Venkateshan. It is going to be a 4-hour session on the day 4. And let us start with Dr. E. Annadevi for the session 1. And the title is going to be Green Sustainable Agriculture. So Dr. E. Annadevi is the Associate Professor at the Satyabama Institute of Science and Technology, and she is going to be the speaker for the session 1. We welcome you, ma'am. The session is all yours. You can start, ma'am.
Thank you, ma'am. Am I audible?
Yes, ma'am.
I thank Iei for giving me this wonderful opportunity to talk about a wonderful topic, sustainable green agriculture. So let us start. So to start with, now let us look at the trends that is happening in the planet today. So the onset of the industrial age brought about various trends that has led us to the today's present state. When we see from 1700 to till 2000, there is a rapid increase in the population. As the population is going on increasing, the need for food production also getting increased, right? So what is happening? What is the trend in today's is the quick rise in population, the greater need for production, because we have to feed all the population, the entire strength. But at the same time, the urbanization is getting increased. The rural people are moving to urban area, right? Similarly, widespread ecological impacts. The thing is, like, we have wide population, we have to feed them, but people living in the village is very little. The little people has to work hard and they have to produce large amount of food products for the entire planet, right? So that is the trend which is happening today. But the agriculture, the farmers has to work hard, and this is not only prevailing in India, but it is all, this is trend which is happening throughout the developing country. So when we go on, keep on doing this kind of farming, what is the thing happening is, it is creating the planet, it is affecting the planet, right? So we are producing mass production style of farming. We are following mass production style of farming that has resulted in numerous side effects. So we will see what are the side effects. The side effects, it is not only affecting the environment, but it is also having impact on human being also. First, let us see what are the side effects that is happening to the environment. The biodiversity is getting reduced, habitat is being restricted, deforestation is happening, pollution is happening in air, water, and soil. Okay. Salination, the water is being salinized, desertification, the soil is becoming desert, decline in water resources, and land subsidences. These are all the effects of same kind of production or same kind of agriculture which is produced in mass production style. Because of that, the environment is getting damaged in this way. Similarly, human impacts is farmland destruction, damage to soil fertility, reduced nutritional value of the food, decreased economic, social, and cultural values. So the past several years, research has looked at sustainable agriculture as a potential solution to correct and prevent these problems. So now let us come to the definition of sustainable agriculture. What is sustainable agriculture? Sustainable agriculture was addressed by Congress in the Food, Agriculture, Conservation and Trade Act of 1990. Under that law, so under that law, what is defined as sustainable agriculture is an integrated system of plant and animal production practices having a site-specific application that will over a long term satisfy human food and fiber needs, enhance environmental quality, make the most efficient use of non-renewable resources, sustain the economic viability of farm operation, as well as it should enhance the quality of life for farmers and society as a whole. That is, in general, we can say that the farmers, everyone in the planet should feed, right? Should have a full tummy, and they should live a happy life. They should have a high quality of living. At the same time, they should not create any damage to the planet Earth. Right? So that is the ultimate aim of sustainable agriculture. We are living happily in this earth, right? Similarly, our other generation, the upcoming generation, the next upcoming generation, the generation which are coming after a lot of years back, they should also enjoy the same planet just like us. That is the ultimate aim of sustainable agriculture, right? So agriculture is a holy profession. But the same thing, it should not damage, create, or any damage to the planet, right? So whatever we are given by the God to us, we should maintain the same kind of it to our following generation also. That is the ultimate aim of sustainable agriculture, right? So the goals of sustainable agriculture, the main goals of sustainable agriculture is to minimize the adverse impact on the immediate and off-farm environment while providing a sustainable level of production and profit, right? We should have a large quantity of production. The farmers should get a lot of profit, but at the same time, they should not create any harm to the environment. That is the aim of this. That is the main goal of sustainable agriculture, right? So you can define this in three sectors, you can say. That is, the agriculture which are performed should be environmentally friendly, right? It should not create any harm to any part of the planet. Similarly, they should be economically viable, right? Viable means they should earn more, they should produce lot of product, they should have earn more profit. Just like any other profession, the farmers also should get a huge money, right? They should also have a high style of living, high lifestyle they should have. At the same time, it should be socially acceptable, right? They should have a piece of life, piece of living, right? Simply stated, sustainable agriculture refers to the ability of a farm to produce food indefinitely without causing irreversible damage to ecosystem health, right? We should not cause any damage to the ecosystem. At the same time, we should also get plenty of food that should feed lot of population. That is the ultimate aim of sustainable agriculture. Okay, so for this traditional methods also, our ancestors also followed lot of traditional method for this, but in the recent years, due to industrialization, many methods have been changed, and these are the effects of that one. So traditionally we are following these methods. Today 80% of production, crop production, they rely on waterfall, rainfall only. Even with that, they are doing like a crop rotation. Every season they will be using different types of crop, not using the same crop for the entire year. They will be using crop rotation. Natural fertilizers are used to feed the crop. Raised fields, terrace fields, irrigation canals, swamps and lakes, home gardens, tree culture. These are the traditional methods which are used for following the sustainable agriculture traditionally. In today's method, we are using crop rotation. That is to predict to predict what will be giving you maximum profit from the soil. You will be growing that kind of crop in that particular soil. Similarly, various pest control strategies are used to reduce the harms that are created to the pest and to gain the more profit. Increase mechanical or biological weed control, soil and water conservation practice, strategic use of animal and green manure, use of natural or synthetic inputs in a way that poses no significant hazard to man, animal, or the environment. Okay, so these are the sustainable agriculture methods you can do. Sustainable agriculture, you can rotate crops. Crop rotation can be used in order to keep the soil healthy. Mixed forms allows the use of livestock manure. Conserving natural area protects our environment. Small change in this practice can help rather than harm the environment, right? So creating a small change in our lifestyle can create a lot of useful things to save the environment. Grass livestock weeds. So nowadays livestock are not allowed to not given grass feed. They are given other artificial man-made food, right? Science can determine the right amount of fertilizer and pesticides. So you can use the you can seek the help of science for determining how much fertilizer is needed, how much pesticide is needed, rather than using a large quantity of fertilizers and pesticides. Farming removes nutrients and fertilizers or manure replace them. farming multiple crops across farms to reduce their financial risk by having multiple products to sell. So farmers also will be living a very good and very happy life in this planet. So for this, as engineers, what is our role in improving this, in helping the sustainable agriculture? We, particularly electronics engineers, we are there to give them a good help, like smart agriculture. When we talk about modern agriculture, we can say, define two terms, agri-tech and smart agriculture. What do you mean by agri-tech? Agri-tech refers to the application of technology in agriculture. If you are applying a particular technology in the field of agriculture, that is called as agri-tech. But smart agriculture on the other hand is used mostly to denote the application of IoT solution in agriculture. Today, we'll be discussing about the smart agriculture so that we can yield more products at the same time creating less damage or no damage to the environment, right? So that the agriculture will be sustained for long period of time, as well as Mother Earth will be sustaining without any damage, right? So that is known as smart agriculture. We are going to do agriculture in a smarter way by the help of IoT. So what is smart agriculture? By using IoT sensors to collect environment and machine metrics, farmers can make information decision and just improve every aspect of their life, just from livestock to crop farming, right? So it is that you can make your agriculture more smarter. If you want to monitor your crops, if you want to monitor your livestock, you can seek the help of IoT, right? So thereby, lot of time, lot of money, and lot of your hard work can also be saved, so that smart work can be implemented. Okay, so that is known as smart agriculture. Now coming to IoT based agriculture. IoT based agriculture is one of the recent topic or recent trend which is happening in it's an upcoming topic, right? But in the field of agriculture, it is in India particularly, it is not yet fully developed. It is in a starting stage because our farmers are not in a because our farmers are not in a view to accept this IoT based agriculture. They are slowly or gradually developing this IoT based agriculture. Okay. So in fact, as per current trends, the smart farming market share is set to reach $6.2 billion by 2020. At the same time, the global smart agriculture market size is expected to triple by 2025, reaching $15.3 billion. Okay, so actually there are a lot of opportunity in this field, particularly in IoT based agriculture field. So if you are interested in IoT and if you are particularly interested in agriculture, there is a wide opening is there. Just improve your skill and you can develop lot of products which are helpful for sustainable green agriculture. Okay, so market is still developing. There is still ample opportunity for business willing to join in, right? So building IoT products for agriculture within the coming years can set you apart as an early adapter, as such help you pay the way to success. So if you are anybody is interested in developing IoT based agriculture products, IoT based smart homes, smart data, this and all is already available, but IoT based products, it's in a developing way. So if you are interested, you can upgrade your skill and improve that. Now, how does your smart farming benefits the farmer? How does the smart agriculture is helping you, or how does this IoT is helping you in doing smart agriculture? It helps in 5 ways. You can collect data, tons of data collected by smart agriculture sensors, right? So when you talk about agriculture, you have a lot of crops, machines are used, cattle are used, livestock are used, right? So if you have sensors all over there, the sensors will be giving the information about the soil, about the other parameters, about the livestock, about the climate, everything you'll be getting lot of information. They are data. Data are nothing but information. If you look at raw data, it is nothing. It's like zeros and ones. But if you organize and if you analyze that, that will be giving you lot of information about the environment. Like if you get a proper information about your environment, and if you could plan that, you can efficiently implement the plan, and if you can efficiently achieve your goal, right? So by using IoT, the base of IoT is sensors, right? Different types of sensors will be used for different application. From the sensors, we can collect lot of information, and that will be giving you an idea, right? That is the first thing. Second one is better control over the internal process, and as a result, lower production risk. So the farmers, they will be farming a traditional method. They will be growing crops, right? Say they won't worry about what will happen what will happen if the products are not sold, what will happen if the products are not needed by the particular at the particular time, but by a group of people, they don't worry or they don't have any idea. But if you go for this IoT based application, it will be giving a what to say, a process. It will be saying about a process, and it will be giving you a rough calculation of what is needed in the market at what time and how can you produce that. It will be giving you, so that you can say that you can say like this products which is needed in the market can be grown by the farmer at the right time, so that the product won't lie around unsold. All the products which are produced by the farmers will be given to the market, and they will be successfully sold, and the farmers will be getting enough profit, right? So that can be, so IoT helps us to predict what is needed in the market at the correct time. So thereby, that is the second point. Next one is cost management and waste reduction thanks to the increased control over the production. So IoT helps in seeing all the anomalies in the crop growth, livestock health, and you will be able to mitigate the risk of losing your yield. So if a plant is affected by a disease, the disease will be spreading to the next plant. The entire field will be destroyed by a particular plant. But if this IoT is there, the IoT will be giving you at the initial stage itself, it will be giving the farmers the information like the plant is being destroyed or it is being attacked by this kind of diseases. So immediately the farmers can look into it and it can stop the growth of that disease, right? Similarly, livestock health can also be monitored by our IoT sensors, and it can be taken care, and the life can be saved, right? So you can say that it can mitigate the risk of losing your yield. Okay. Next one is increased business efficiency through process automation. So we are using smart agriculture. So smart devices will be used, and at right time, the right process can be turned on and off by using IoT technology. Thereby, a lot of process can be done in an automated way instead of using manual operation. Lot of process can be done automatically, like irrigation. Smart irrigation is there wherever the farmers are there. For farmers are being farmers are, they can just by clicking on a mobile, they can turn on or off the motor and give irrigation to that field which is remotely, which is present far away, right? Similarly, fertilizing also can be done like that. Pest control also can be done like that. These are all actually challenging jobs which need more manual operation in agriculture. This can be done automatically. So automation is given there, which can save money as well as which can give more efficiency also. Then enhance product quality and volumes. So this will be giving you high standard of quality, high standard quality, because it is monitoring your crops all the time. 24/7 sensors are monitoring your crops. So thereby the products can be produced without any damage. The quality of the product will be increased, as well as the production volume of the products also will be increased. As a result of all these factors, the farmers will be getting high revenue, a high profit, and high, which will be giving them a high standard of living. Okay, so these are the benefits of using IoT in smart agriculture, or we can say smart agriculture, which is used for sustainable agriculture. So now let us see some type of IoT sensors cases which are generally used in smart agriculture. So first one is for monitoring of climate condition. India is a country where we have different types of climate, where unexpected weather conditions and unexpected calamities will be happening. So this kind of gadgets will be helping the farmers in a very easy way, as well as to predict what is happening, right? So for monitoring the climate condition, you can use Almitio, smart elements, and Techno. These kind of devices will be giving you the measurements like what will be the climate condition, what kind of crop will be suited in this climate condition, what type of farming can be done across this area, the soil, how does this soil quality is there, which crop if you grow will be giving you maximum profit. This kind of information, every information will be given by these devices. They can use greenhouse automation can also be done by using that, like for growing a particular crop or a plant, some amount of lighting is needed, some temperature is needed, soil condition is needed, humidity is needed, right? So this greenhouse automation, this is a device, you can say. It will be giving like whatever facility needed for the particular plant, it will be monitoring, and it will be automatically giving that much amount of light, that much amount of temperature, that much amount of humidity. Okay, so this is along with that, you can use like farm app or grow link app, which will be continuously giving you the growth of your plant. Okay, so green IQ is also an interesting product that uses smart agriculture sensors. So this is also giving the plant whatever it is, just like a mother giving an affection to her child. So it will be taking care of the plants 24 bar 7. Okay, so that is known as greenhouse automation. Third one is crop management. This is also yet another product. So it will be giving, it will be, you can put the product in the farm. It will be monitoring the growth of your plant continuously, starting from the seed till it gives the fruit, or till it gives the yield. So the need for this kind of crop management is, if at all a crop is affected by any disease or any pest, right, at the starting stage it will be giving you daily it will be monitoring, and daily it will be giving you a report about the growth of the particular crop. How does it is growing? It is growing in a good manner, it is this much amount of growth has been done, it is in a right way. It will be giving all your what to say, the entire growth of your report can be collected by the farmers who is living apart from the field, right? So if a crop is affected by any disease, or if there is any anomalies in in the plant or the crop, immediately the information will be given to the farmer. Farmer can come and he can uh, he can take any recovery action and save the particular crops, right? So that the harm that is going to happen in the crop can be avoided. So that is an important or very useful tool, crop management tool. Next one is, this is a very essential thing, cattle monitoring and management. So when you talk about agriculture or smart agriculture or sustainable agriculture, we cannot talk without cattle. Cattle play a very important role in agriculture, right? We all know that, especially cows, goat, sheep, whatever may be. But at the same time, if you see, if you want to take care of your cow, nowadays it is very costly for uh, taking care of the cow. You have to appoint a special person who has to take care of the cow, who has to feed him, who has to take for grassing. Like, but when you are going for this IoT based applications like SCR by Alflex or Cowler, there are a lot of devices available for, especially for this livestock managing. Now in this picture, you have the collar at the collar of the cow. So this kind of IoT devices will be giving you the entire report about the health of the cattle, right? It will be monitoring, it can be used to monitor a particular cattle, as well as for a herd also it can use, right? So day by day report will be given to the farmer regarding the health of the cow, whether the temperature is normal, how does the physical activity is going on, how much distance it is walked, right? So the entire operation you can it will be given as a report. Suppose if it is having any disease, I mean, if it is not well, if your pet is not well, or if your cattle is not well, that information also will be given, so that the particular cattle can be separated from the herd and it can be taken to the vet, or some extra care can be given. Okay, so that is very essential and very important thing. Similarly, for when you are feeding or when you are taking your cattle for grassing, right? So at that time also you can use the help of GPS, and you can use this kind of cattle monitoring and management system for feeding your cow, right? So no person should be there to take care of the cow around for grassing, right? So that is also there in IoT based smart agriculture. Then next comes the precision farming. What do you mean by precision farming? Accurately, this IoT smart agriculture technique will be giving you how much yield you can produce this for this season. How much mangoes will be ripened this time? How much profit will be getting? How much what is that? What is needed in the market also it will be giving you. How much product you can produce, that also will be given. Okay, so this is called as precision farming. If we follow the smart farming or smart agriculture, we can go for this precision farming. as also be known as precision agriculture. It's all about making efficient and making accurate data-driven decision. Okay, so accurately, if we need to produce 100 tons of food product, the same 100 tons of food product can be produced in the form real time. Okay, so by using IoT sensors, farmers can collect a vast area of metrics on every facet of the field: microclimate and ecosystem lighting, temperature, soil condition, humidity, CO2 level, and pest infection. So for this precision farming helps a farmer in a lot way, right? Sometimes if you see tomatoes and all, it can survey for 1 or 2 days, maximum of 1 week, not more than that, right? So most of the tomatoes will be like it will be wasted without like unsold, right? Similarly, not only tomatoes, lots of food items, lot of fruits, right, they are being destroyed or damaged without getting enough return, right? So this CropX and MoTV, these are apps or this kind of precision farming tools help the farmer to take decision which will be giving them precision farming, exact what is needed. How can you generate that? It will be generated. Okay, that is called as precision farming. Here comes the agriculture drones. So agriculture drones nowadays are playing a vital role in smart agriculture. So UAV is nothing but unmanned aerial vehicles. These drones are better equipments than aeroplanes and satellite to collect agriculture data. First of all, we need we want data. Data is very important thing for smart agriculture, right? So we have to entirely analyze about a particular area to know about the particular soil or particular field. Then only a decision can be taken, and the what to say, the farming can be done, right? So without having a proper data, if we go and do a simple farming or simple agriculture, if you are doing, it will not be giving you enough result. You cannot get enough returns. Okay, so this UAV is unmanned aerial vehicle or drones. They are very much helpful in collecting the data from an unmanned area, right? Places where human beings cannot go, or in an deep forest, or it will be giving you a lot of information about that. Second, we are using drones nowadays for sowing seeds. Drone seed, particularly drone seed, it will be used to uh, what to say, throw the seeds, or it will be used for growing trees in deforested area. In forest which has been destroyed, for to grow the plants again, we are using drone seeds. This kind of drones is 6 times more efficient than human labor. Think about that. So that because of that only we are moving slowly to smart agriculture. So if a human being is planting seeds and taking care of them, this drone seeds can do 6 times more efficiently than a human labor. Okay, so 6 times more the plants can be sown and the trees can grow, and you will be getting a good forest again. Similarly, a sense-fly agriculture drone uses multispectral image analysis to estimate the health of crops and comes at an affordable price. So the sense-fly is also a commercially available drone. So it is used to detect the diseases using image processing techniques. So how does it happen? It will be taking image of the leaf or whatever may be the crop. Then using image processing technique, image analysis, it will be calculating which kind of diseases the plant is there, or the plant is healthy, or any diseases it is being affected. So it will be giving a clear-cut idea about the health of the plant. Okay, so that is agriculture drones. Next one is predictive analysis for smart farming. This already we have discussed. Prediction is very important, and the prediction also should be precision. With the precision, the prediction should be there. So what is needed by in the season, if we grow, what can be grown in this particular farm, that should be predicted priorly. And if you take any action based on that predicted analysis, you will be getting maximum yield. Like this soil can help you grow this kind of plant, means you should grow that kind of crop at that time. Okay, so our IoT sensors along with data analytics algorithms, it will be giving you a clear-cut idea about what can be sown, what can be harvested, what can be sold, everything, right? So the predictive analysis which comes is nothing but an data analytic or an algorithm type of data analytics which is used in accordance with IoT sensors. Okay, So the best example is crop performance. This helps farmers access the volume and quality of yields in advance, as well as their vulnerability to unfavorable weather conditions such as floods and droughts. Right. So it will be predicting at what time floods will be there, droughts will be there. So how can you withstand that? What type of crop if you grow, you will be getting, you can withstand that kind of climate condition that can be predicted. Based on that, if you are using, you can get maximum yield. Okay. Next one is end-to-end farm management system. So this management system is giving the farmers a clear-cut idea about from the starting stage till the end, till the profit, till the marketing, everything. It will be giving you a clear-cut idea. It's just like a app, right? Farm logs and Cropio or best solution for this kind of application, crop management application. Okay. So fine, we are using lot of IoT based ideas or IoT based solutions are available for making the agriculture more smarter. But at the same time, there are various challenges in developing countries like India for adapting this kind of solutions. Okay, what are they? The hardware, the brain, the maintenance, the mobility, infrastructure, connectivity, data collection frequency, data security in agriculture industry. Now, let us see these challenges also, because if we mitigate the challenges, then only we can have a proper smart agriculture. Okay, first one is hardware. Hardware is IoT cannot perform without a hardware, right? It may be a sensor, or it may be Arduino, or it may be a Raspberry, whatever may be. There should be a hardware in the field, right? So the hardware, the main element of this IoT is sensor. A lot of sensors are available. You can also customize your sensor, customize your, based on your need, you can have a customized sensor. But the sensors should be made and it should be deployed in the field. That is the first hardware, right? First challenge. It is not always possible to deploy sensors in the farm. Next one is the brain. The brain is, even though the sensors are deployed in the field, the sensors will be giving lot of information from the field. They will be remind just ones and zeros if you are not analyzing this data properly. So the brain of our IoT is data analytics capability. You should analyze your data properly and make it as a useful information. From the information, you should use predictive algorithms and predict the nature, right? So you should have a proper data analytics algorithm, or else the data will be remaining data, right? So the next one is the brain. Third one, an important thing in for Indian agriculture is maintenance. Maintaining your hardware is challenging and a very important thing for IoT products, because our the hardware is in the farm, and the farm is facing sun and what rainfall always, right? So there are chances that they may get easily damaged. Proper repair as well as maintenance work should be done properly, right? That is also a very what to say, challenging one in India. Maintaining the hardware part in the field is a challenging one. If the hardware is failed, you should detect that and you should replace with other sensor, okay? Or else you'll be getting wrong data. That will be again creating lot of disturbances to the things. Similarly, you should have mobility. The mobility, smart farming application should be tailored for the use in the field. The business owner or a farm manager should be able to access the information remotely via smartphone or desktop computer. So everyone should access the data. Accessing the data is very important. For accessing the data, you should have a mobile phone or a desktop or a computer. Nowadays, everyone is having this thing. So slowly we are moving towards a successful smart agriculture. Next one is smart infrastructure, right? So like you should have a proper infrastructure for collecting the information from the sensor. You should be given to the gateway. From the gateway, it should reach to the cloud. From the cloud, you should reach the farmer, right? So you should have a proper infrastructure is needed. And connectivity means you should have a Wi-Fi is needed. In general, we can say that a proper net connection, Wi-Fi connection is needed for the sensors for performing its job, right? So in India, like country, due to bad weather condition and other natural calamities, this connectivity is often getting disturbed, right? But still, our 5G technology and other things are slowly developed. After this pandemic, the internet is being gradually increasing, and we have a lot of solution for this connectivity issue also, as well as data collection frequency. So if you go on collecting the data, collecting the data from the field, it is also of not use. So how far frequently you are collecting the data, the field-based, aerial-based or environmental sensor application, machinery and equipments, as well as the processed analysis data can be subject of restriction and regulation. So there should be a restriction and regulation for collecting the data. Okay. Similarly, security, data security is also there. It is a wild field. The field will be it's widespread, right? So your data, the data which is collected by you can be easily hacked by the next farm owner. So there should be a proper security in collecting the data, and the reverse giving the instruction also. There should be a proper data security should be maintained, either by at least by using cryptographic algorithms. So security in data collecting in the agriculture field is a challenging job. Okay. Now, these are the challenges and these are the useful things of IoT-based agriculture or smart agriculture for helping sustainable green agriculture. Okay. Now, I'll explaining you two important IoT techniques, right? Everyone knows that, but just we'll be having a glimpse of this IoT-based smart agriculture and how can we control animal intrusion also. Okay. So, first one is IoT-based smart irrigation. So this is the architecture of IoT-based smart agriculture. So we should do the things smarter, right? That is the ultimate aim. But at the same time, it should not create any harm to the environment. We want a lot of production, but we should not harm anyone. That is the ultimate aim of smart agriculture. The first one or the simple idea for this is IoT-based smart irrigation system. Okay, so this is the architecture. We have sensor nodes all over the field. It is given by SN, and the walls just for sprinkling the water in the field. You have walls. Then again, the walls will be connected to wall controller. The information from the sensors will be given through RF wirelessly through the gateway. From the gateway, the information will be given to the cloud. From the cloud, the data can be accessed using apps in the mobile phone or in the desktop or in the laptop. Okay. So what the idea is like, we have a lot of population. As the population is growing on, we need to produce the food for all the people. We have to feed everyone. So here comes the IoT based smart irrigation. So even the farmer need not visit his farm day by day. Every day he need not visit his farm. IoT will be taking care of his farm and give the data needed by the farmer day by day. So the thing, IoT based irrigation works in this manner. You'll be having sensors. Sensors can be grounded or placed everywhere in the farm, right? It will be collecting the information, and through the information through the gateway, the information will be IoT Wi-Fi or gateway. It will be given to the cloud. From the cloud, it will be given to the IoT platform, right? IoT app. Just like it will, the sensors now, in particularly in our IoT-based smart irrigation, we'll be using soil moisture sensor, right? So I'll show that soil moisture sensor. This is the soil moisture sensor. It has just like a copper electrode. So this will be measuring the moisture content of the soil, whether the moisture content is good or it is bad, right? It will be, first of all, it will be measuring the moisture content and give the information to Arduino or Raspberry Pi you can use. So Arduino will be measuring how much is the soil content. It will be giving the information to the cloud. This is the soil content is less, right? For example, if the soil is dry, right, it will be giving the information to the cloud. Cloud will be giving the information to the farmer. Through SMS also, it will be saying the moisture content of the soil is less. It is time for making the motor on, right? It will be giving an information, right? So the farmer just get the information. He will be seeing, okay, there will be an option for on or off of the motor. So he'll be clicking turn on the motor, right? So that the information will be coming back from the cloud to the field, right? So the field will be receiving that, and we have motors will be there. Relays will be connected to the motors. Motor will be turned on and the valves will be open, and you'll be getting water fed to the plants or the crops in the farm. Okay, so here the step one is the farmer has to enter the username and password. They have to give the command on and off for the application. Okay, so in the field, the IoT based platform collect and send analog data. The GSM shield in Raspberry Pi will be giving you command, and the soil content or the moisture content of the soil will be measured and it will be given, and the farmers will be receiving the information need to turn on or turn off. Based on that, they will be clicking on. The information will come back to the farm and the motor will be turned on. Okay, farmer is getting the SMS and he can turn on or off just by clicking an on off button. If the soil content is moisture content is very less, he can turn on the motor, and immediately when motor is turned on, water gets sprinkled out and the farm get irrigated, right? After some time, what will happen? The soil moisture content will be increased, soil will be the enough humidity will be maintained, then again it will be giving an information to the farmer. Now the moisture content is fine, then the farmer will be looking on and it will be he will be turning on off the motor, right? So the motor will be off and the farm will be getting irrigated. This is a simple operation which is instead of going a person to the farm, instead of checking the form, we can do it remotely. Okay, so this is a system workflow for doing this. Start, you can give your login ID, user ID and password. You can give the command. The moisture content will be measured, and water level detector sensor also you can use. How much water level is prevailing in the field, it can be measured, and the information will be given to IoT based platform using microcomputer as well as Arduino. If you talk about Arduino, you have a hardware part and you have a software part. In the software part, program should be written properly, and based on that, it will be executed. If the moisture content is less than 50, it means that the water level is less, right? So the farmer has to turn on button, then the motor will be turned on, then again the data will be converted to action, right? You will be having an activator, so the motor will be turned on, the valves will be sprinkling, so again the moisture content will be increased. Okay, so you can stop the operation. So by doing that, what are the advantages? Water conservation, wastage of water can be avoided. At the same time, needed water should be used by the field. Real-time data are given, lower operation cost is less. You can save efficient time. Production also will be increased, reduces soil erosion and nutrient leaching, right? Or else what will happen if when a person is going to the farm, he will be turning on the motor, he will be feeling how much time I have to wait, let me go somewhere. If you go somewhere, the water will be filled and it will be wasted, right? It leads to water wastage as well as soil erosion also will be there. Nutrients also will be wasted, right? These can be allowed. But the thing here is again, we have issues like complexity, but slowly we are moving. Privacy and security is there. Less, we are going to reduce our manual staff. Equipments are somewhat costlier. And the final thing is, Indian farmers are not aware of this technology. Slowly, educated people, they have to move to agriculture. They have to slowly accept this and they have to slowly implement this. Okay. So it is in coming in the next 5 to 10 years, surely we'll be achieving all these things. Okay, so that is the important thing, smart agriculture, which will be surely making India a smarter India. Next one is animal intrusion detection. This is also a very, very essential thing because the planet Earth is not only for human being, it is also for other living things, animals, birds, plants, everyone, right? So we should preciously protect the animals also. But there are always conflict between human being and animals, always, right? So we don't want to them to move into our area, but actually we are living in their area, right? So lot of conflicts are always happening between human and animals. Okay, recently everyone know human elephant conflict, particularly in South India it is happening more, right? So if you see here, we are having electrocution. We are human beings. We human being will be using normally doing electrocution for protecting our field, our farm, ourselves by from the wild animals. Okay, so lot of animals are being killed, particularly by electrocution. 1,300 wild animals killed by electrocution in India over a decade. Okay. Similarly, snakes also. Lot more number of varieties of snakes are available in India, but they are disturbing our living. They are disturbing our farms. So snakes are regularly being killed. But government nowadays, they are putting high penalty as well as cases are being filed if you are killing snakes. Okay, so snakes regularly killed, despite they will be creating risk to wallet as well as health also. So, but how can we save our farms from the wild animal? No other way. We have to say, because if a single wild animals, if it enter our farm, it will be creating entire damage to the farm, sometimes to our lives also, right? So that is also important. So what are the effects we are taking is, so human being will be putting electrical fencing around the farm, right? So now electrical fencing is legally not an accepted one, right? So also power supply lines coming from the high tension wires also, they are giving, right? So this is not an acceptable one. Government has taken serious effort to overcome this electrical fencing. Okay, so what can we do as engineers? We can seek the help of IoT for overcoming this electrocution. Okay, so because electrocution causes intense pain in animals, okay, especially in forest zone and agriculture field, human animal conflict is a major problem. There should be a solution for that. So we have come out with IoT based animal intrusion detection. So what can we do is a simple idea. We can have cameras and PIR sensor, passive infrared sensor. So using that, we can monitor who is moving inside your field, right? So the PIR sensor works in a manner, it has two slots. One slot will be sensing who is moving inside. It will be particularly monitoring warm-blooded animal, and it will be giving you the information uh, whoever has that is an animal has moved inside, right? So whenever the PIR sensor feels that someone is crossing your field, right, it immediately initiates the camera. Okay, so camera will be taking the picture of so you have to deploy a lot of PIR sensor, more number of PIR sensors based on the size of your field. You have to deploy more number of PIR sensors and more cameras all around your field. Okay, so this camera PIR sensor will be monitoring whenever a warm-blooded animal is crossing your field. So next thing is you have to segregate whether the intruder is a human being, a pet animal, or a wild animal, right? So for that, PIR sensor cannot do that, right? For that, we are seeking the help of camera. Immediately, when any warm-blooded animal is moving inside the field, as soon as the PIR sensor senses that, the camera will be turned on. Camera takes the image of the intruder, right? And it will be giving it to image processing algorithm. In the database, we have the pictures of all animals as well as all wild animals as well as all domestic animals, and it will be giving who is the intruder. Is it an elephant? Is it an lion or tiger? Right? If it is an if it is a wild animal, then what will be there is you'll be having a sound, an irritating sound as well as a light will be there. Okay, we can say irritating noise generator as well as a bright light will be created. Okay, so whenever an elephant is moving, actually animals are, they are poor creatures, right? They are scared of us, but we don't mind about them, right? So whenever we are giving an irritating noise and a bright light, immediately they will be getting scared and they'll run away. Okay, that is the main thing, so that it does not damage our field as well as their life is also not damaged by us. Okay, that is the idea. So we can have PIR sensors and camera installed all around that in poles. So PIR sensor will be monitoring whenever a warm-blooded animal is moving inside the farm, and the camera will be capturing the image, and the image can be given to the analysis, image processing analysis, and it will be giving which kind of animal is visiting your farm. Okay, so now we can say that when the animal is there, when a wild animal is entering our farm, what you can do is an SMS also will be sent to the farmer. If needed, call can also be initiated to the farmer, and he can visit immediately. He can come to the farm and he can give the information to forest department. Okay, that is thereby we can save the animal as well as we can save our farm. This is known as animal intrusion detection. This is commercially available nowadays for creating that noise unnecessarily. We don't want to create noise and light always, right? Whenever we find any disturbances, it can be initiated and it can be done. Okay, this is a very useful aspect of IoT based agriculture. So if you do this kind of smart agriculture, if you mix up smart agriculture along with your day-to-day activity, we can achieve sustainable agriculture. But still we are aiming at achieving sustainable agriculture, but there are no strict rules and regulations for to be followed for sustainable agriculture. Okay, but if there are strict rules to follow sustainable agriculture, we can achieve sustainable agriculture also. There are standards and certifications for organic farming, which has similarities to sustainable agriculture, but the two not synonymous. Sustainable agriculture and organic farming, they are entirely different. Organic farming will be using certain types of use of synthetic inputs such as synthetic fertilizer, pesticides, herbicides, whereas sustainable agriculture does not do. It will be using the natural way, as well as it will be using the various recent techniques can be used, but the amount of fertilizers and pesticides will be very less, or no, we don't want to use that kind of thing for sustainable agriculture, because when we use that sustainable health, pesticides or herbicides, it causes damage to the environment. Okay, so in the future, large organic farm that rely on machinery and automation and purchased inputs will have similar sustainable issues that large conventional farms do today. So when we want to maintain a sustainable agriculture, the politics and economics also should help us. Economic incentives may be used to encourage the use of more environmental friendly farming techniques and technologies. Okay, so if you are given more subsidiary or any techniques and be given by the government, then it will be helpful for the farmers to grow their farm naturally. Okay, sustainable practices can save farmers money because of the reduced needs to buy pesticides, herbicides, pesticides. Actually, buying pesticides is a costlier one, but farmers are doing that no other way, right? Sustainable farmers tend to have multiple crop leads to both financial security and subsistences for the farmers. Laws, both local and global, could enforce protective standards. So there should be a strict law which will be enforced not only by the Indian government, by the global government also, to protect standards, to protect the sustainable agriculture. Education of environment situation may help farmers to make better choices. So educated people, when they come for farming or when they come for agriculture in the next generation, surely they will be taking a better choice for making a better agriculture, thereby creating a sustainable environment. So there are a lot of negatives also there when we deal about politics and economy. Sustainable agriculture is constrained by economic growth, right? If you try to follow a sustainable agriculture, you cannot get enough profit. We should have a balance between economic as well as our saving the environment. So development is viewed as coinciding with consumption. There are vast international inequalities of resource consumption, making it harder for many to frame efficiently. Okay, so as educated people, we should follow sustainable agriculture to create a harmless planet for the upcoming generation, to create a happy living for all the human being on the planet. Thank you. Any queries?
Students, audience, do you have any queries?
Okay. Thank you, ma'am. Thank you,
Thank
Anadevi, ma'am.
Yes, sir. Thank you, ma'am, Dr. Annadevi, ma'am. It was a wonderful session on sustainable architecture, that is, sustainable green agriculture. Definitely, it would have been an eye opener for all the electronics engineers to play and contribute more role for the sustainable green agriculture. Thank you, ma'am. Thank you so much. Over to you, sir. Satisha.
Yeah, thank you, ma'am. So I thank to IEI KLC, Kancheepuram Local Centers, for giving this a wonderful opportunity and participation in the Day 5 Asia Books of Records attempt to win the title of Academic and Industry Conclave on Green Sustainability. So the upcoming speaker, Dr. D. Prabhu, Associate Professor, Department of Chemical Engineering, Satyabama Institute of Science and Technology. The topic of this session is sustainability is a product life cycle and sustainability development goals. Over to Prabhu, sir.
Thank you, sir. Thank you, sir. Thank you for your introduction. Very good morning to all. And today we are here to convey the lecture on Academic and Industry Conclave on Green Sustainability, organized by the Institution of Engineers India, Tamil Nadu Center, the Kancheepuram Local Center. I thank the organizers for giving the opportunity to talk in this forum. And today's my lecture deals with the sustainability, deals with the product life cycle, sustainable development goals. So what is the environmental sustainability? So when we discuss about in detail about the environmental sustainability, before understanding the environmental sustainability, we like to know some introduction about the population growth in India. So if we see the graph, we can understand that India, you all know, like India has about 17% of the world population, and people living in urban areas alone, 1/4 of the total population. And one important thing we need to see here is more than 16% of the population who have age less than 35 years. Okay. The growth percentage is 1.6% per year. According to the population and land area, the India ranks second in the world in terms of the population. And compared to the USA and India, the land area of USA, it is 3 times more than India, whereas in the population, India is 3 times more than the USA. So the ranking by total annual carbon dioxide emissions. So if we compare the various countries, according to the data given by 2013, India stands on the 4th rank of the ranking of total annual carbon dioxide emissions. So ranking by per capita carbon dioxide emission in terms of metric ton. So in India, have 1 to 2 metric ton per person. So compared to China, China is 3 times more, whereas the UK, Germany, Japan is 7 times more. Compared to the USA is 10 times more than the carbon dioxide emission released to the environment. So before understanding the sustainability, we need to understand the different phases of the product life cycle. So for any product which is coming from the industry to the customers, it has to go through the different types of phases. So this is a product life cycle, and then input and outputs. So what are all the various input we need to do, synthesize the product? We require the material, we require the land area, we require the energy to manufacture the product, we require the raw material like water. So these materials has to go through the product life cycle, and then what are all the various output or where the impact of the product is. So it emits the emissions to the air, and it discharges the water bodies, and most of the solid waste materials is filled in the landfilling operation. So what is the impact of the product life cycle is? So global warming, you all know, like global warming is a major factor in environmental scenario, and then there will be some climate change, acidification problem, ozone depletion, deforestation, desertification, and the release of toxic substances, and eutrophication problem arises, and finally it leads to the biodiversity losses and soil erosion. So this is a various different life cycle, product life cycle, and then input and output and the impact of the products. So if you take the product life cycle alone, so if you see the materials, we have different process to make a material. For example, we do extraction of raw material. During extraction, some amount of pollutant is coming out, and the next step is a transportation, and then processing of raw materials, transportation of raw materials, and then production and manufacturing of the building materials and product components, and then processing of components. So this material alone will have a different physical operation, unit operation to carry it out, and it will release a lot of emissions, a lot of wastes to the environment. The second factor, assembly. So once you make the material, it is taken for the assembly section. So if you wanted to make assembly, if you wanted to agglomerate, or if you wanted to combine the material to a new material, we require that transportation process, and we require the assembly process, and it also utilizes the equipment and the application of electricity for the plant and office, and then the usage of water. So these are all the various parameters which is involved in assembly of a product life cycle. In case of operation, so once the material, once the product is going to be operate, so it has to be used with the customers. So the customers utilize the electricity in terms of fuel during the life cycle, and also it requires the maintenance, servicing, repairing during the period of operation. And finally, in the product life cycle, the disposable comes into picture. In case of disposal, for example, if any equipment failures occur at any process, you cannot able to achieve the thing, and we need to go for disassembly and dismantling, and sometimes we go for a recycling and reusing the product, and then through transportation, and finally some of the solid waste management system we used to follow some landfilling operation, and incineration operation. And these process from starting from the materials to the disposal will require a lot of process, and also it releases a lot of emissions to the environment. Our idea how to go for controlling, how to go for sustainability comes into picture. So now we understand what is sustainability. What is sustainability? It's the ability to sustain something for an indefinite period of time. For example, if you're going for producing the material, we need to take into account without depleting the resources. Okay, for example, we need to consider the future into account, and we need to make the material. And also during the usage of resources, we should not damage the surroundings, especially the environment. The term sustainable, it is used to understand the many different areas. For example, the sustainable design and sustainable development, sustainable living, and then sustainable energy. So one of the important scientists, Dr. J.C. Kumarappa, in case of Academy of Fermions in 1930, he has given that the definition of sustainable development: manage economic growth in such a way as to do no irreparable damage to the environment. That is said to be the sustainable development. So if you are going for managing the economic growth, it should not repair, it should not damage to the environment, it should not cause any damages to the environment. So if you talk about the sustainable engineering, it can be applied. The definition for sustainable engineering, it strives to maintain some sustainable principles in engineering activities. For example, if you are going to minimize the environmental damage in order to produce a food, water, shelter, these are the basic necessities for human beings, and then mobility for growing world population. So whenever we make sufficient engineering, whenever we make the sustainable engineering, we need to keep it into account that we have to minimize the damages in order to provide the sufficient food, water, shelter, and then movement of the growing population. We have to take into account, and then designing the products and process so that so many wastes are also coming into the picture. So in order to do sustainable engineering, these two factors, along with that, we have to incorporate the environmental and then social constraints and consider the economic consideration to take the final decisions. Sustainable engineering is a process of using energy and resources at a rate which should not compromise the natural environment, and also it should have the ability to compromise the future generation needs. So as a sustainable development, it is given by the United Nations General Assembly in 1987. The definition is development which meets the needs of the present without compromising the ability of future generation. The overall goal of sustainable development is a long-term stability of the economy and the environment, which only achievable through the integration and acknowledgement of economic, environmental, and social concerns. So these are the definitions given by the United Nations General Assembly. So what are the main concept of sustainability, what we're talking about? There are three pillars in sustainability. One is the economic, another one is the social, another one is the environmental. So also it is informally called as the profit, which relates with the economic, and planet, which relates with the environmental, and then people, which relates to the social. So sustainability is an integrated approach. So we have a socio-economic approach, we have employment, we have training and development sector, local economy, entrepreneurship development, and social community and sponsorship. In case of social, you have like respecting the individual, giving equal opportunity to all, diversity, employee assistance, human rights. In case of economic alone, we have like profitable economy, growth of the economy, risk management, shareholder return, and then eco-economy, considering the economy with the environmental, ecology, resource efficiency, improving the energy efficiency, reuse, recycling. In the environmental sustainability, so we talk about the permit and license, compliances, biodiversity management, carbon management, and emissions. And finally, the socio-economical and environmental factor includes health and safety, climate change, and then Seveso-Comac and crisis management, and finally the business continuity factor. So in the case of differences between the economic as well as the social and then environmental issue, we can take the different quality of life. For example, if you take a water, so unsustainable factor, if you have a high cost of drinking water, it is said to be the unsustainable one. Sustainability is nothing but availability of drinking water at a low cost. So if it is a social issue, if you take a water in the case of social issue, access to drinking water to the denied or weaker section, there won't be any variance. There won't be any like a richer or poorer. Water has to go to all sectors. In the case of sustainable factors for social issue, adequate water supply to all the persons. And then environmental, there won't be any pollution comes from the getting into the lakes and the rivers, and it should be sustained for freshwater bodies. If you take the food as a life's concern, so an unsustainable thing comes from high cost of food and usage of fertilizer more and pesticides. and sustainable good food. Another one is organic farming, also is very important here. In the case of social issue, the food has to go to the weaker section, and in the case of sustainable issue, adequate access to the good food, all the sections. And environmental sections, we talk about more pesticides and chemicals usage, and then deforestation. And then sustainable factor for food is nutrient quality, which is related to the diseases. And the energy sector, so what is the unsustainable factor here is economic point of view, high cost and intermittent power supply. So sustainable electricity should be available at low cost. And social issue, the over usage of energy by the rich society. So it should contribute a problem, and adequate energy it should be supplied to all the persons. It is common as sustainable factor. Environmental issue, the energy comes from the fossil fuels, it creates a lot of pollution, whereas we need to go for renewable resources. So we talk about some of the technological applications of sustainable development in various sectors. Number one is sustainable agriculture technology. Sustainable agriculture integrates the three main goals. One is environmental health, economic profitability, and social economic equity. So how to achieve the sustainable agriculture? What are the common ways to achieve? One is said to be the IPM, as Annadevi ma'am explained about sustainable agriculture in detailed way. But here I'm going to tell about what is integrated pest management system is one of the important common way to achieve agriculture technology. Rotational grazing, soil conservation, water quality, wetland creation, cover crops, crop and landscape diversity, and the nutrient management system, and then agriculture based forest. These are all the sustainable agriculture technology methods. And if you see the sustainable energy, so what you talk about sustainable energy, the energy which has to be produced or consumed without creating any negative impact to the human health, and it should be create a healthy environment, vital ecological system to the global environment. So you all know like what are the renewable energy sources like solar, biomass, wind, tide, and geothermal heat. So we have to follow these renewable energy sources in order to give a sustainable energy and energy efficient system to upgrade the efficiency of the existing equipment, reduction of energy loss, saving the fuel, and finally go for optimization of the operating conditions. So what are the various signs of irreparable damage in ecosystem? So ecosystem, the damages arise from the polluted rivers in metro cities and depletion of groundwater resources, alarming the air pollution levels, irregular rainfalls, and then impact on agriculture, and then shortage in the availability of natural sun. These are the various signs of the irreparable damages arises from the ecosystem. So if you see the ecological concepts, as I already told, one is the product life cycle. So what are the various products, how to achieve the product? And another one is we have to minimize the toxicity level. Hazardous material, should not use any hazardous material to make any fertilizer or pesticide or any chemicals. And we can use some biodegradable material, and you have to maximize the renewable energy. And finally, we need to concentrate on diversity and adaptation. So what are the three pillars of sustainability? The one is said to be the environment, another one is economy, another one is the society. So three P's are said to be the planet, people, and profit. And three E's are said to be the environment, equity, and economy. So this is said to be the sustainability metrics. So you have seen that triangle shows the topmost layer is economy, and middle you have sustainability, in between you have environment and society. Economy includes affordability and life cycle cost, and the environment includes energy, production of carbon, material synthesis, influence of water and land acquisition, and then society includes the safety, environment, health and well-being, and aesthetics. And apart from that, you have some functional requirements in sustainability metrics or service life, durability, serviceability, flexibility, adaptability, and modular components, recycle and reuse factor. This is said to be the sustainability metrics. So now the other topic in our lecture is sustainable development goals. So we need to know, before understanding the sustainability, environmental sustainability, we need to know what are the sustainable development goals, SDG, to understand. So it has started from January 2016 to 2030. They given the global goals, which is given by the UN. What is defined as what do you mean by the global goals? Universal call to action to end the poverty and protect the planet and ensure that all people will enjoy the peace and prosperity. So this is the main objective of designing the goals of sustainable. So in 2000, they have created like 8 millennium goals, and now they have 17 goals to achieve for sustainable development. So it includes new areas such as climate changes, economic inequality, and then interconnected with achieving the, it is all goals are interconnected. Not to achieve one goal, it depends upon the other goals. So let us discuss about the different types of sustainable development goals. goal 1. So in right hand side, the picture shows what is a goal 1. So it is like no poverty. So there should not poverty in all forms. So we should end the poverty in all its forms everywhere. So second goal is zero hunger. So it should achieve the food security. We have to improve the nutrition, and we have to give a sustainable manner and promote the sustainable agriculture. Okay. So zero hunger will take care of the food security and sustainable agriculture more. And then goal 3. So in order to provide a good health and well-being, so we should ensure the healthy lives and promote the well-being for all ages. That goal 3 stands for good health and well-being. And goal 4, the quality education. We have to provide the quality education, ensure the inclusive and equitable quality education, and then promote lifelong learning opportunities. Okay. So sustainable in quality education is very important. Okay. So learning is not a end. You have to, it should continue for a long time. Lifelong learning, we have to create an opportunity to study lifelong, and we have to upgrade the education. And goal 5 is gender equality. So empower, we have to empower all women and girls in the society. And then goal 6 stands for the clean water and sanitation. And we should ensure the availability of the clean water and sustainable management of the water and sanitation for all. Its goal 6 stands for clean water and sanitation. And goal 7, affordable and clean energy. So we have to provide affordable to all. The energy should clean, it should be reliable, and it should be sustainable. And modern energy, for example, if you're going for modern energy like energy from solar, energy from wind, tidal, or ocean, it should be like modern energy. We have to use some modern technology to obtain a clean energy. And then goal 8, you have to provide a decent work and economic growth. So we have to promote a sustained and inclusive. It doesn't cause any problem to the workers. And economical growth, sustainable economic growth is a goal 8. And then goal 9, so where we talk about the industry, innovation, and infrastructure, III. So we have to create a resilient infrastructure. For example, if any industry have any problem like natural calamities, is going to stop it, but we should take care that the industry is going to run in a long basis. It should be resilient infrastructure we have to build, and we have to go for innovation. You have to go for finding out the new product, and then infrastructure for constructing the infrastructure of the industry. So we have to provide a sustainable material. We have to use a sustainable industrialization and innovation come under the goal 9. As goal 10 of sustainable development goals, it includes reduced inequalities. So we have to reduce the inequalities in the societies within and among the countries. It is very important one. And then goal 11, it creates sustainable cities and communities. So we have to make the cities and human settlements inclusively, safety, and resilient and sustainable in nature. And goal 12 includes responsible consumption and production. So once you produce a product, it should be ensured that it should be sustainable consumption, and the production pattern will be in sustainability. And the goal 12, responsible consumption and production, and goal 13 leads to climate action. So here we take urgent action to combat the climate changes and its impacts. So we have to use a technology, and we have to use a natural technology to combat the climate action. And then goal 14 goes with the life below the water. So here we have to conserve and sustainability using the ocean, sea, and marine resources for sustainable development. So we have to conserve the water, we have to conserve the ocean, we have to conserve the various water resources, marine resources for the development. And goal 15, so goal 15 stands on life on land. So we have to protect, restore, and promote the sustainable use of terrestrial ecosystems. And we have to go for sustainably managing the forest, and we have to combat the desertification, and we have to halt and reverse the land degradation. We have to stop the land degradation, and we have to halt the biodiversity loss. So once we concentrate on these factors, we can able to do sustainability in land. And the goal 16 stands for peace, justice, and strong institutions. So we have to promote the peaceful and inclusive societies for sustainable development. And goal 17 stands for the partnerships for the goals. So strengthen the means of the implementation and revitalize the global partnership for sustainable development. So in order to achieve the goal 17, so we need to concentrate more on goal 6. So clean water and sanitation. So if we have an ensure availability of water and sustainable management of water, so we can do the clean water sanitation along with the partnership, so we can achieve the goal 17. So these are all the various sustainable development goals. So apart from that, what are the various roles of the engineers to have a sustainability? Environmental engineers have to go for new technology development for water and wastewater treatment, and then river water quality, and then the role of hydraulic engineers to create the efficient irrigation systems, and then reduction in water leakages, and then flood protection. And if you are going for water resources systems, engineers will take care of the system thinking, optimum designing, and then evaluation of the plan, and then decision support systems. Ecologists will take care of effect on ecology, and then environmental flows. The scientists come under social, they have planned socially acceptable, helps in making a policy frameworks. And finally, the economist is also very important. One economist, if you talk, the stakeholders comes into picture. They are more involved and they are the integral part of the sustainability. So what are the stakeholders, different types of stakeholders, and the area of interest in sustainability factor? The politicians, their main role is provision of basic services, creation of the job, and then city officials will concentrate on cost and ease of maintenance. Private developers will increase the profit and go to the public persons, and community groups will involve in job creation, public health and safety, and then environmental groups will create the protection of the environment. They safeguard the environment from the effluent, and individuals, each individuals will have additional costs and benefits per fold, and these are the different stakeholders. So according to the one of the important definition, the Brundtland Commission of UN of March 1987, so there is given that sustainable development is development that meets the needs of the present without compromising the ability of the future generation to meet their own needs. So this is the, so to be the three sectors like social, environment, and economic. So these three circles where it cuts that it has a bearable and sustainable and viability is very important here. And one of the important daily rules approach based on the Nicholas GR is given by, according to the Daly's rule, the ecological sustainability can be defined as we should not use the renewable resources, example, fish, groundwater, at a rate faster than at which they regenerate. Okay. So we should not use renewable resources in order to approach Daly's rule. And we should not use non-renewable resources like fossil fuels at a rate faster than the rate at which correspondingly. And we should not emit pollution and wastes at a rate faster than the rate at which natural ecosystems. So these rules should be most directly followed by the Nicholas and GR. And we have a sustainability index to carry out. So based on the concept of emergy, embodied energy, and another concept given by Odom in 1956, given a procedure for accounting for the energy. According to the sustainability index given by the Brown and Ugarte, according to thermodynamic concept, the available energy of one kind that is used up in different transformations, directly or indirectly to make a product, an expression of all the energy used in the work process will generate a product or service in unit one type of energy, and it measures the quality difference between the different forms of energy, and it accounts for different forms of energy and resources, example, solar, water, fossil fuel, minerals, etc. So each form of energy have generated by transformation process in nature and has ability to support in work in human as well as the natural system. And this is at my end of the topic. Thank you. Thank you for one and all those who are listening my lecture. So if you have any doubts, so next. Okay. So we'll move to the next session. So next session is chaired by Dr. S. Satish. Sorry. So next session is chaired by Dr. D. Venkatesan, Associate Professor, Department of Chemical Engineering, Satyabama Institute of Science and Technology. So he is going to deliver the lecture on sustainability in process engineering. Over to Venkatesan sir. Please wait. The event will start now. Ma'am. Karthikeyan sir. Venkatesan sir, is it audible?
Yes, sir. Prabhu sir, good morning. Am I audible?
Audible, sir. Ma'am, Karthikeyan sir. Ma'am, please make Venkatesan sir as host, ma'am. Co-host. Karthikeyan sir.
Sir, they made it, I think.
Okay.
Venkatesan sir, you can start, sir.
Yeah, Satish, sir, can I start?
Yes, sir. Yes, sir. Please.
Okay, thank you, sir. Thanks for dear participants. Very good morning to one and all present here. and myself, Dr. D. Venkatesan from Department of Chemical Engineering. And today I'm going to share something about sustainability in process engineering. I hope I am audible to everyone. Let me allow me to share the slides first. Okay. So sustainability in process engineering. So let us understand the topic first, sustainability. So the morning, almost 2 lectures, they have explained very clearly about sustainability. And these are nowadays most common word everywhere throughout the world. People are keep on talking about sustainability, and they are conducting so many conferences and submit. Okay, so higher end meetings between the countries and making agreement between the countries to work towards the sustainability. Can you type in the chat box what is your understanding about sustainability? 1 or 2 answers. Participants, am I audible to everyone?
Make full screen, sir.
Yes, madam. Is it visible, madam? Madam, is it visible? Screen is full visible.
So Venkatesan sir, full screen பண்ணுங்க.
No,
Yes,
sir.
now I am showing, but when I'm making full screen, it is the screen sharing is paused. Now, madam?
Now okay, sir.
Okay, thank you, sir. Yeah. So one answers from Ria. Sustainability refers to the idea of making something last longer with lesser side effects. Very good. Positive impact. Very good. So it's simple. Okay, everyone have a clear idea or understanding about sustainability. It means that whatever the resources available for all the living organisms. We are always talking about only human beings. In this environment, there are so many species. So the environment is always favorable to all the living organisms. Okay. So whatever the resources are required to lead our day-to-day life, it should be last longer. So whatever the statement mentioned, it's very straight away it is mentioned. We need to keep that resources for next generation to next generation forever, so that they can lead their life happily without getting any harm. Generally, if you are not talking about the sustainability, obviously whatever the activities people are doing, it's not only engineering sectors, day-to-day activities of all the human beings. Okay, either individual activity or group of activity, or through industry or through residential areas or any sectors, always people are contributing certain amount of work to environmental degradation. Okay. uh, I'm going to talk about today about the engineering aspects, process engineering especially. So you all know that what is engineering. Engineering is nothing but basically the applications of science, the respective field. Okay. For example, if it is chemical engineering, the application of physics, chemistry, maths, and economics, or bio engineering or biotechnology means application of their respective field. Similarly for computer science, and similarly for civil engineering, whatever the disciplines are there. And as we all know that engineers know the contributing a lot to the society. Okay, shaping the society in a better way and to have comfortable life. Am I right? That is why people are working towards that. But that should not damage to the environment. So that is the way we need to think, because generally we won't think about whenever we are introducing certain technology or any products or any commercial products, we will not look into the side effects in the sense how it is going to harm to the environment. Okay. So generally we will see the application of that particular product only. Later once we are disposing that, either end of the application or while you are producing that particular goods also, people won't think about much about how we are affecting the environment. So as I said, engineers always contributing a lot to the shaping the society. And similarly, engineers only making more contribution towards the degradation of the environment also. So every individuals and especially engineers will have a lot of responsibility to work towards sustainability, because then only you can provide this environment for the next generation forever. Okay, so let us have again recall certain terminologies. What is sustainability? The ability to sustain something for an indefinite period of time. So that is most important one, without depleting the resources used to sustain it, and such that it does not damage the surroundings. That is very, very important environment in which it resides. The term sustainability is used for many different areas, not only for engineering or environment or anything else. So it is common terminology used for all the areas, like design. When we are designing anything, we will always focus on sustainability of that particular design. Sustainable design, sustainable development, sustainable living, sustainable energy, sustainable all the resources, okay, it's etc. So generally people used to use the terminology. So if you apply what is the concept of sustainability to engineering oriented, then we call it as sustainable engineering. If you are applying that concept towards process engineering, then we call it as that is sustainability in process engineering. So generally what is process is a change of state. Okay, so according to our requirement, whatever the materials are there, we will transform that one into useful products, okay, for the end application. So generally in the process side of process, that we call it as process, whoever is the making that process, especially engineers, we call it as process engineers or process engineering. Okay, especially when we are producing chemical, we call it as chemical process industry. If you are producing any medicines, then pharmaceutical industries. Okay, if food, you are producing any food related items, then food processing industry. If you apply the previous definition to engineering, we could say that sustainable engineering strives to maintain sustainable principles in engineering activities, such as the using methods that minimize environmental damage to provide sufficient food, water, shelter, and mobility for the growing world population. Okay, designing products and process so that the waste from one are used as inputs to another. That is now people are making always that zero discharge waste. Okay, so whatever you process, okay, anything it may be. See, for example, you take mobile also. Once the mobile, after the usage of mobile, when it is not in the working condition, so obviously what people used to do, it is a waste. Am I right? They will throw it out. Or there are nowadays people are collecting this electronic, and there is a concept called electronic waste, and they are recycling and they are taking out the useful products from that waste product. Okay, ultimately their aim is to reduce the waste disposed into the environment. Otherwise, there are many chemical substance present in that, particularly in that electronic substance or whatever the substance we are just throwing. You take one simple example. When you are going to the shop, people always used to give along with the plastic bags only. The plastic bag is made up of chemicals only. When we are disposing that one into the environment, so it is leads to the pollution. Okay, related to all the pollution. Similarly, whatever we are throwing, okay, so you need to think about what is the impact on that particular substance onto the environment. Okay, so and before that we need to think. Okay, so that is whenever engineers, they are the most responsible person to making any industry to produce goods. So obviously we are in a position to release lot of substance to the environment that should not destroy the environment. Okay, so people keeps on talking about the climatic condition. The temperature keeps on increasing every summer, and during the rainy season we are getting sometimes intolerable heavy rains. These are all the things happening due to environmental changes, climatic changes. That is because of the way we are taking the resources from the environment. Okay, we are exploiting the lot of resources and we are throwing a lot of waste to the environment. So due to that, the entire climatic changes is happening. So designing products and process so that the waste from one are used as inputs to another. So ultimately, when we are designing any process or products, and we need to think about that whatever the waste is produced from the product, that should be minimized. Okay, so that the wastage, whatever we are going to dispose, or the another way we need to think how we can convert that waste into useful products. Okay, so that is the way you need to think as a engineer. Okay, so incorporating environment and social constraints as well as economic considerations into the engineering designs. So sustainable engineering is a process of using energy and resources at the rate of that does not compromise the natural environment or the ability of future generations to meet their own needs. Okay, so I hope you all heard about the tissue paper. Okay, it is made up of from special tree, and every year, especially from Western countries, they are cutting the tree at the rate of 2x or 3x times of more than that. Okay, so you all know the deforestation, and people should think as engineer, what is the alternate way you can produce the tissue paper without cutting the trees, and how to maintain that resources so that we can provide good sustainability environmental conditions. Okay, so and of course these another important terminology. Okay, economic uh, the terminology is most widely used everywhere. It's the most important one also. The economic sustainability ensures that the industry or business is making profit without creating much damage to the environment or ecology. Okay, the long-term economic growth without negatively impacting the social and environmental and cultural aspects of the community. Okay, the economic growth is expressed in terms of all we know that GDP, gross domestic product. This is the total amount of production produced within the nation, GDP within a 1 year. The economic growth has to be sustainable if it improves quality of human life. So obviously you all know there are some few countries their economy is going down like anything, especially our neighbor countries, Sri Lanka and Turkey is facing another problem. Okay, see, once the economy is going down, obviously you will face a lot of problems. Okay, so the sustainability is not only in engineering aspects or design or process or related to environment. Obviously, we need to think about economic related also. Otherwise, the lot of issues will started coming, and it's very difficult to maintain the peaceful environment. And the population factor must be included to ensure fair resources consumption. Okay, we will see a little bit later. And chemical engineering. So why I have taken the process engineering here, chemical engineering is these are people who is more responsible for environmental impact, as well as the person who is responsible for day-to-day life activities for all the chemical substance. You take pharmaceutical or any industry, you name it, without chemicals, it's very difficult to produce any substance, because the chemicals are playing very important role in all areas and especially in day-to-day life. So as I said, what is engineering? Same thing is applicable for chemical engineering also. So it is application of science, mathematics, and economics. Nowadays, economics is default. Okay, because you name it any country, either it is developed country or underdeveloping or poor country, that is categorized based on economics of that particular economy of the country only. Okay, so that is why it's not only for management people. The engineers also should know about the economy. When we are talking about the technology, people is to do, there are two. One is optimizing that particular technology. Another one is economy of the technology. So how much it is economically feasible, either it is affordable. Okay, affordable, and whatever money we are spending, we can able to take it back. So that calculation you can do only through economics only. So chemical engineering is the application of science, physics, chemistry, biology, and mathematics. Of course, it's common for all engineering, and economics to the process of converting raw materials or chemicals into more sustainable forms. The term economics and sustainability are very important here for both. Okay, so it's very simple, just converting the raw material into useful products. Okay, especially in terms of chemicals. So that is nothing but chemical engineering. And you can see here this diagram, and generally people will use, these are all the resources: air, natural gas, coal, minerals, biomaterials, and a lot of other inorganic, organic chemicals. And they are using this science of concept of science, chemistry, mathematics, economics, physics, and biology, using the concept of science and converting into useful products. Okay, there are a lot of products through process only people used to produce. Am I right? So there are two concepts. One is unit operations and unit process. So work with unit operations for purpose of chemical synthesis and separation and chemical reaction, mass and heat transfer, momentum transfer. So generally, whatever the process we take, no, there is a law behind in that. So generally, we will apply some physical laws. Conservation of mass is common one. Everybody aware of that: mass, energy, and momentum. And applying the principles of thermodynamics, reaction kinetics, and transport phenomena, and design and operate the process. Okay, these are all the concept where generally people will use in chemical engineering and producing or converting the raw materials into useful product. So more than just process engineering applies chemical knowledge to create better materials and products that are useful to our modern society. The core of chemical and biochemical engineering deals with, as I said, a conversion of raw materials to useful products, finding the optimal synthesis routes and operating the processes for their designed application and through use of science and mathematics and economics. You can see this diagram, so you will have the better understanding. So these are all the resources, raw materials. So generally, either it is most of the time, most of the raw materials are from natural way people used to get from the environment, and it is getting into the process, the synthesis routes by using reaction, separation, mixing. These are all the unit operation, unit process involved in this process. So this process, whenever you want to carry out certain process, we need to have certain equipments designed, okay, devices, okay. So that in separation, especially distillation, reaction engineering, reactor, okay, evaporator, crystallizer, mixture. There are so many equipments, okay, generally people used to have to produce certain products. So there is a operation and design of that particular equipment, and operating that equipment, we call it as production. By operating this process, we will get the products. That product is needs, actually there is a end application is huge, and this is the way people are converting the raw material into products. And you can see here this diagram, you can understand the raw materials. See, generally why we are talking about the science. See, the science and engineering together, no, they have to come together in order to produce certain products. And especially in no, nowadays people keeps on talking about the sustainability. Whatever the projects, no, the new projects or the technology, and whoever is introducing, no, people always ask this general question. So what is the sustainability in that particular project? Okay, so because it's very, very important, we need to keep this resource forever for all the generations, okay, in order to have their life without any struggle. So these are the resources, raw materials, whatever I said. So we will have the concept of science, and by using that concept of science, no, and we will convert that one into product. For that we need engineering knowledge, okay, and innovation process product, okay. So where generally engineers know, as I said, whatever the product we are producing, so that should be eco-friendly. And one more thing is, after the usage of that product, no, we should have certain technology to recycle or reuse or reduce the waste. So that way we need to think about the innovation. And of course, there are certain cases you cannot avoid producing the waste, is that you have to design in such a way that the waste should be very, very minimum, or that waste should be converted into another useful product. So that way it can be recycled, okay, throughout, so that no, it will not damage the environment, okay. And any process, especially for chemical engineering aspects, so people are always focusing, okay, whatever the product you want to produce, you will have certain byproducts, and you will have certain unconverted reactants also, okay. So now people are working towards that micro level concept, and taking that means converting all the raw materials into useful product. So it means that people are working towards 100% conversion. So when you can able to do such type of innovation, then you will not find much problems. Am I right? You will not find much problems, because you are not going to handle much equipments. You see, for example, I will take one simple example. Ammonia synthesis. So we all know that what is the raw material for ammonia synthesis? Nitrogen and hydrogen. So when we are taking nitrogen and hydrogen into the reactor and putting into the reactor, if we can able to convert all the nitrogen, all the hydrogen into ammonia, then we need not to use any separation process. Okay, so that way you can minimize your energy, that way you can minimize your water if water is used, and that way you can minimize your materials in the sense you need distillation or crystallizer or evaporator, whatever it is related technology or methodology is used, that you can minimize. So only you can take the entire ammonia and that can be used for various purpose. Okay, so now people are working towards that, and how we can convert all the reactants into products. If you can able to come up with such type of technology, then we can minimize, okay, minimize the waste. Maximum we can minimize the waste. Now people are thinking towards eco-friendly product, bio-based. Okay, thinking and towards the bio-based. So that is always eco-friendly. So the core, however, needs to be supplemented by appropriate levels of science and engineering to find sustainable and innovative solutions. And sustainable and innovative solutions can be found through an appropriate mix of science and engineering. These two people should come together. Okay, come together, because the science, where you will get a lot of new ideas that can be transformed into commercial product with the help of engineering knowledge. If these two people are working towards producing the products in sustainable way, then okay, we can minimize a lot of wastage and we can have sustainability. Okay, you can see now the current and future challenges, sustainability issues, and current and future survival. The world population is expected to reach around 11 billions by 2050. So not only in human beings, whatever the living species in this world, the population is increasing like anything. Obviously, the natural resources, we will exploit. Okay, am I right? See, whatever the material you are producing, you are taking from the environment only. Okay, so obviously, we need to, if overexploiting obviously leads to a lot of issues. You can see here increase in water, energy, and commodities demands. See, for example, here global GDP growth over next to 50 years in constant dollars around 6 to 7 times. So 6 to 7 times it has to increase, 6 to 7 times of X. So then only we can able to maintain that GDP, and everybody can live their life without any much problematics. And you can see the production capacity for most commodities, materials, steel, chemicals, lumber, whatever the goods are required for day-to-day activities, that it has to be increased around 5 to 6 times. Then you can imagine the production rate, how it has to be increased. And energy, the most important factor for day-to-day life activities, as well as for any industry to run, we need energy. Energy almost demand is going to increase like 3.5 times X. So obviously what we need to do, so we need to meet the requirement. Am I right? The engineering, the responsible job is to meet the requirement of the people. So obviously we need to think the technology which will meet the requirement, and the technology should be eco-friendly. It should not destroy the environment. And electricity demand, obviously you can see almost 7 times it is increasing. Okay, the water demand increases almost. Water demand also will increase, and GHG emission also will increase. Greenhouse gases, it is also keeps on increasing due to population. Obviously, if the population is more, the usage of the commodities, water, energy keeps on increasing. And this is a schematic, the way to understand how people are doing. See, converting the resources to products, how they are converting the resources to products by using a lot of resources, like especially energy and water, and the environmental impacts and produce waste. So this is the where now the world is facing a lot of issues due to this technology updation. Okay, because everybody is they are good in producing the goods to meet the requirement. So once the application is over, once it is disposed, the people are not having much technology how to recycle, now how to minimize that particular waste. So obviously you are getting a lot of waste, and it is dumping in the environment that leads to a lot of problems. And you can see natural resources converting into goods and services for our comfortability. And after that, it's directly impacting on the environment. So pollution, waste, and environmental disturbances. Okay, so this is the way it's happening. Still, it is happening, but people are working towards how to minimize this. So only 25% is converted, okay, and must be greater than 40%. So it means that obviously we need to think how to minimize this waste. Okay, so how to do, or how to maintain, or how to have the innovation technology to have sustainability. So again, there are a lot of factors we need to consider. So we need to educate the people, and obviously we need to have the science knowledge and engineering, okay, and sustainable solution always providing. We need to keep water, energy, and resources. No, that is very challenging opportunity in order to maintain that all the resources forever. And innovative solutions. Obviously, when engineers are always thinking new technology, people are going always updating the technology in order to have more comfortability. Am I right? More comfortability, and they want to make, of course, they want to make profit also out of that. And application industrial development. These all people should come together, and in order to face the challenges in the world. The overall objectives are to serve the society through educating the necessary engineers who can apply their education, training for industrial development, taking advantage of the opportunities available, and addressing the challenges being faced. Okay, it's not only the engineering people. So every individual should have minimum idea, the basic concept of environment. Okay, so what is the importance of the environment? Everybody should be educated, and everybody should be aware of that. So technologies to make process and products more sustainable. So where the people are now working towards that, how to make the technology which will help you to maintain or to have more sustainability. Okay, so there are certain factors we need to consider. Improve the efficiency with which natural resources, including energy, water, and materials, are used to meet human needs for chemical products while avoiding environmental harm. And this is the most widely used concept: reduce or eliminate the use or generation of hazardous substance in the design, manufacture, and use of chemical products. Okay, so very, very important factor. We need to reduce or eliminate. We need to find some alternative methodology. Protect and benefit the economy. Obviously, economy is very, very important for all the country and people and the environment using innovative chemical transformations. Considering all life cycle stages, including manufacture, use, and disposal. I'll show the figure. When evaluating the environment impact of a product, and minimize the use of non-renewable resources, the most important one, because it is going to one point of time, it is going to be depleted. Okay, it is not renewable one, non-renewable resources. And you can see this diagram of life cycle of chemical process and products. Okay, so this is the raw material, and we started converting into chemical products, useful products, which is used for many activities. And the industrial, if it is used after the industry, it is disposed. Okay, how we are going to dispose? That is a really big question mark. People always think how to convert that one into useful product. Okay, chemical process, and it is going to product use after the usage of that the post-consumer waste disposal. After the usage, how we are going to dispose? The main concept here is how we can convert the disposal, taking the disposal and again converting that one into raw material and making again product. If we can able to do that, no, then we will not dispose much materials or much chemicals to the environment. The concept call it as recycling. So keeps on, we are reusing and recycling. So the disposal into the environment will be minimized like anything. The sustainability of, actually we have taken here one example, sustainability of the solvents. So you all know what is solvent, okay? So it's mainly used in process industry, especially in chemical industries. And the usage of solvent is really, really huge. Okay. The rethinking solvent use in a number of different applications is another approach to increase sustainability in the chemical industry. So instead of disposing, no, we can think about reuse. A solvent is a substance capable of dissolving other substance in order to form a homogeneous mixture known as solution. Okay, so we all know that solution is nothing but solute and solvent. And basically, you are taking the solvent to dissolve in order to perform certain things. So the chemical industry uses solvents for several different purposes, including number one, for media for chemical reaction. There are certain cases when you want to carry out certain reactions, we need medium, and especially they will take certain amount of solvents. In the separation and purification of chemicals, also people used to have solvents. See, for example, whatever the oils, edible oils we are using, no. So people, there are two methods. One is chemical method, another one is mechanical method. So mechanical method, you all know that the grinding, okay, the normal conventional way, but it's very difficult to meet the demand. Okay, the huge usage of edible oil is really huge, and we know that Indian population how much. So people are finding to meet that requirement chemical method, that is solvent extraction method. So they will crush all the seeds and they will add that solvent. So the oil is visible with that solvent. It will extract all the oil from the seeds. Okay, and after that there is a separation. The solvent is mainly to extract all your oils from the seeds. So hexane, one of the solvent is hexane, is mainly used in making the edible oils. Then obviously we should know how to recover that and how to reuse that. Otherwise you have to dispose. Okay, that leads to a lot of problem. And cleaning the equipment used in chemical process. Okay, so there are certain cases you want to clean the equipment to perform other operations. Obviously we need solvent where your things can be get dissolved and it can be cleaned. Okay, so solvents may also be included as a primary component or ingredient for in formulated products such as paint, ink, or cleaning and personal care products. This use can be interrelated. For example, the choice of reaction medium can be facilitate the separation and purification of product. Okay, so this is simple to understand, taking the substance 1 and substance 2 and taking into the solvent in order to prepare the homogeneous solution. That means completely dissolving and getting the homogeneous solution. Technology to make solvent use more sustainable. So what I'm trying to say here is, so solvent is playing very, very important role in process engineering. Either you want to carry out certain reactions or you want to use solvent for separation, like extraction process. The solvent is playing very, very important role. Absorption process, solvent is playing very, very important role. So whatever the solvent we are going to use, so obviously it is also produced. Okay. So the one way when we are talking about the sustainability, so we need to think about the solvent which is more sustainable. That means that should not harm to the environment, and it can be recycled and it can be reused for many times. So that way you can minimize and disposing the chemical substance into the environment. So you need to find, and there are many methodology to produce solvents. Just I will give the brief, the flavor of, there are bio-based solvents. So people have to concentrate more on bio-based solvents for production, as well as suppose you want to use any solvent for your process, try to identify or try to choose the suitable solvent which is more sustainable and non-volatile organic compounds, solvents, especially water. Water is the best solvent. The another solvent is solvent-free or reduced solvent. So these are all the areas. These are all the three major types of solvents which is helping to maintain the sustainability. Okay. So just a minute. Okay, thank you. Dear participants, thanks for your attention. Thank you so much.
Thank you,
Dr.
sir.
Satish, sir.
Thank you, sir. Thank you, sir. Thank you for your nice presentation on renewable solvents and green synthesis which is used in the process engineering. Thank you, sir.
Thank you, sir. Thank you so much.
So you can stop sharing. So good morning to one and all present here. I am Dr. Satish, head of the Department, Chemical Engineering, Satyabama Institute of Science and Technology. So I welcome you all for the fourth session on the day 5 on IEI Asian Book of Records series in the topic of industry academic conclave on sustainability. So when you see that the topic of this session is biorefineries from the perspective of the sustainability, feedstocks, products and process, a way to sustainable environment. From the 3 sessions, we understand that the sustainability is not only the stopping the resources of current scenario, but we have to preserve the natural resources for the future generation in the way that we have to optimize the usage of natural resources. That means the ability to sustain something for the future generation without depleting the natural resources and not damage to the surroundings. So the term sustainability is used in the various areas in like engineering, design, and environment. As the second session, third session, which Dr. Venkatesan delivered, that the sustainability parameter in the process engineering, how the solvents can be selected, what are all the process modifications can be selected, that is the engineer. And in the design and development, in the second session by Dr. D. Prabhu explained the sustainable development goals, how we are making the life cycle analysis and how we are processing the design. And from the session 1, we are discussing about the sustainability in agriculture. Now we are seeing that sustainability in biorefinery that will produce energy and also which will save the environment. So sustainability living, when you are seeing that, it will be produce a profitable growth. At the same time, it has to be a cost efficient, innovative marketing, and you have to get the profit over that. So that's the way we have to think over it, by minimizing the utilization of renewable resources, and you have to produce an environment friendly substances. When you are seeing about the sustainable engineering is the process of designing or operating systems. You can design or you can operate it by such that it will be used for energy, alternative energy, and resources, which should be a sustainability. So you will incorporate the principles of sustainability and make the design over it, so that that design will be applied in the field of engineering, or based on the engineering principles, you can develop a technology, alternative technology, which will mitigate the measures that will cause the environmental damage. Either it may be a product based or it may be a process based. Thereby, you will change the lifestyles, which will be eco-friendly lifestyles. So based on this sustainable engineering, we are using the methods of waste to wealth, converting the waste to in the form of wealth as a useful sources. And you have to minimize the waste generation, reduce the waste generation by using the recycle and reusing concepts. And you can modify the technology, as I already mentioned, either in the way of process or in the way of products. Changing of the raw materials is the one technique, or using some other novel technologies which will becomes that also a process, and taking a different products, that and all you will comes under a technology modification. When you are discussing about the sustainable design, it's reduce the negative impacts on the environment and also the negative impacts to the health, thereby the increasing the efficiency of the overall process. So the process or basic objectives of the sustainability is reduce the consumption of non-renewable resources, utilize maximum renewable resources, minimize the waste, and be environmental friendly productive environments, and create healthy lives. This can be achieved by performing various R&D activities and education informations. That the motto of this program's industry academia conclave, where the research and development and the academic education knowledge, which brings a new material and new normal situations in industrial design, engineering design, economic design, environmental design, that leads to sustainable design. So where you will utilize the maximum natural resources which are renewable and low consumption, low energy consumptions, like what we are using a coal for production of energy, that will be consumed less because we are having alternative fuels and alternative resources for energy productions. Thereby, you will not deplete our environment, and we have save our environment healthy, and also you can preserve the resources for future generation. Now, the topic which comes as environmental sustainability. What it requires? Environmental sustainability requires a natural capital which is available, and maintenance of biodiversity. To maintain the biodiversity, we have to need an environmental sustainability, because this planet is not only for humans, it is also for all the living organisms which is there in our planet. And we have to maintenance of the energy. So nowadays the problems we are facing on the global warming because of the large emissions of vehicles and also from the industrial effluents. So by means of utilizing a bioenergy, we can reduce the usages, and at the same time we can reduce the emissions that contaminate the environment. At the same time, we can use the optimized use of energies and maintains the material cycles of the planet and health and resilience of all life support systems. How can we achieve the environmental sustainability? By reducing the usage of non-renewable resources, effective use and fair distribution of resources, consideration of biodegradability substances instead of non-biodegradables, preferring biodegradable substances. Nowadays, bioplastics are emerging because you know that plastic contaminate the environment, and we are achieving the 4R techniques: reduce, reuse, recover, and recycle. Reduce the generation of waste, reuse, recover whatever the valuable materials from the waste, reuse it, and recycle in any other forms. Thereby, you will achieve an environmental sustainability. Now, today goals, what we have from the session 4, we understand the process and technologies available for deconstruction and conversion of plant biomass into a valuable resources as a form of energy or value-added chemicals or steam and electricity. As you know that fuel, we need a biofuel, biodiesels, which can be used blended with the diesels, as the cost of diesels and petrols are rising day by day. So we are producing a biofuels that will be reduce the consumption of the biodiesel, which is producing by all normal process, petroleum refinery process. We can go for biorefinery process and blended with the petroleum refinery products. Thereby, you can use the optimum use of that fuels. And chemicals, most of the value-added chemicals we can recover from the wastes that can be used, that cellulosic products and all that we will discuss in this session. And steam, the process industries can't run without steam and electricity. So there we can use this biomass conversion into a fuel or value-added chemicals or steam and electricity. And we should apply the concepts of microbiology, chemistry, engineering, and for the analysis, designs, and scale up of the operations, equipments, process, which will be used for the conversion of biomass into bioenergy. So we should adopt an integrated process for converting this biomass as a waste to a value-added products as a wealth, bioenergy, biofuels, or biomass derived products. So when we are discussing about this biorefinery, the 3 valuable products which we can get it is biofuels or bioenergy or derived chemicals, biomass derived chemicals. Now, this session will identify the current technological challenges and the bottlenecks and the hurdles that that will be facing when we are employing or adopting these technologies. First, we have to understand what is petroleum refinery. From that, we can move on to a biorefinery. As you know that petroleum refinery, we are producing various products like gasolines, LPG, naphtha, petrol, kerosene, diesel oils, lubricating oils, fuel oils, and wax from crude oil. So the problem majorly we are depending on the crude oil from various exported services. So, and we are dependent on them. So technology also we are depending. So technology to produce different products required for human development. Either it may be a vacuum distillation unit or atmospheric distillation unit or naphtha cracking unit. So we should adopt the technology for the development and also the cost associated with processing and profitability. As you know, the profit will be there in the refinery industry, that the cost for the capital cost for the installation of these equipments and refinery constructions, which will be considerably more, and cost associated with that and processing fees for operating costs, that also will be higher, because we have to import the crude oil and we have to process it and we have to transport into stations where you are refilling stations. So the more cost is associated with processing and also the profitability parameters. And the distribution of products, you know that it is multi-component distillation. We are getting up various products in the various levels of the distillation products. So we have to distribute the products and we have to purify the products, and we can get the products which will be used for the human development. As a basics, we know that hydrocarbon fuels, which is having a petroleum gas, what we are using in the domestic applications, liquefied petroleum gas without the carbon of C1 to C4, that is 1 carbon to 4 carbon. And naphtha, which is used for producing further products, benzene, any aromatics or any other substances, we can use naphtha or ligron with the carbon contents of C5 to C9. And gasolines, where alkanes and cycloalkanes with the carbon content 5 to 9. Kerosenes, which is used in the domestic applications, where the carbon content is C10 to C18. And gas oil or diesels, which is having C12. Lubricating oil, which we can use for motors or any other grease purposes, we are having a lubricating oil with the carbon content C20 to C15. So fuel oils, which will be used for the industrial purposes, which is having C20 to C17, and the residuals, wax, coke, asphalts, which is having the carbon content greater than C70. So when you are comparing the source of energy from the past to the future energy requirement, as you see that the green biomass, which will be increasing trend, and the non-renewable resources like coal, which will be in the decreasing trend, as we are focused on biomass. Because you know what, now the concepts which are raised here, the coal usage, the coal source is depleting. So we have to reduce the usage of coal and enhance the usage of biomass for producing the energy or electricity or any other value-added chemicals. When you compare from the 1930s, that biomass, the coal consumption is increases. Now we are reducing from 2020 onwards. We are planning, and the governments also taken initiatives by reducing the consumption of non-renewable resources like coal and gas. At the same time, when you see that the biomass utilization as a source of energy from the past to future, it is in the trend of increasing trend. And you know that the usage of renewable resources, comparing in India and US, in India, we are increasing the source of renewable energy as increasing from 2007 to 2015. For the financial year 7 to 15, it shows that usage of solar power, wind power, and biomass, which will be in the trend of increasing. And also we are using the biomass for all other purposes, for the generation of biofuels and cellulosic materials, corn-based materials. So when you are comparing the total installed capacity of power plant in India, which will have 253.39 GW, that is gigawatts, will be of 12.5% of renewable energy resources, and coal 60%, hydrothermal 16%, nuclear 2%, with oil for 0.5% and natural gas of 9%. So now the national policies of the biofuels will be in India. We are producing biodiesels and we are starting blending of biofuels by the year 2017, we have started a blending of biodiesels and bioethanols, and also the biodiesel productions from not only from edible sources and also from non-edible sources. So minimum support price was announced for the farmers for producing non-edible oil seeds as used for the production of biodiesels. So we are the government taken initiatives by supporting financially and also technically. So financial incentives is given for first generation, for the new generation, that is the fourth generation and the second generation biofuels in the name of National Biofuel Fund. Biodiesel and bioethanol are likely to brought under the declared goods by the government to ensure the unrestricted movement of these biodiesels. And there is a committee was framed, that National Biofuel Coordination Committee under the Prime Minister for the broader policy perspectives, and setting the biofuel standards steering committee and cabinet secretary to maintain the policy implementations. So now we understood what is biorefinery, what is petroleum refinery. Now we comes to our biorefinery and what are the concepts and the benefits. As you know that by utilization of the carbons, hydrocarbons, fuels and refinery products, the emissions, global warming and will be more. But when we are using a biomass, it will be a closed cycle and it will be used recycled manner. We are using renewable and sustainable, and the goods which will be taken from the environment and generate the renewals and to the rural community also, and increase the agricultural development. So we are focused on the agriculture for producing the biomass as the financial supports also given by the government, and produce the energy security and with the high technology jobs. So the biorefinery, we are having the advantages not only in the form of products, and also we are getting the financial supports, and also we are having a happy that we are producing a eco-friendly products which we will not make a damage to the environment. Now, what is biofuels? So fuels which we are derived from the biomass, that is an organic material which is as the source of energy, release energy. So coming to the first generation, we are having various generation of biofuels. First generation biofuels are conventional biofuels, which is the major source, that is the feedstocks for the first generation will be fuels from sugars, starch, vegetable oils. And from the second generation, it is called as advanced biofuels, where you will use the fuels from lignocellulosic biomass. And the third generation, we are producing biofuels from algae. And the fourth generations, now we are using pyrolysis gasification process. So you know that the biomass which are having a natural renewable sources and which are having a renewable carbons, which will not produce, will affect the damage to the air, water, soil, environment, and which will having a limited GHG, greenhouse gas emissions, and which will not create any global warming problems. And the energy which will be produced, it will be in the sustainable manner, which can be used, the resources will not be depleting. Then the soil, because of we are concentrating on an agricultural part, and we are maintaining the organic carbons, and that will be increasing the fertility of the soil also. So we are concentrating on biofuels. Why we are not concentrating on biogas, which will be there? Because you know that liquid fuels are so important, and there are more advantages comparing to the liquid fuels over the biogas. So when you are seeing biofuels as in the form of liquid, which will be easily transportable, and also which will be given energy resources in the form of BTUs, IBTUs. And you know that transportation is easy compared to biogas and natural gas. And we are able to generate the electricity and also the steam generations by using the energy which we will be developed from the biofuels. So you know the scope of bioenergy, biomass, which is an heterogeneous matter, that is nothing but a living organisms which will having includes recently originating from the plants or animals or the microorganisms, directly or indirectly originating from the photosynthesis process. So because we are using algae also, exceptions of lithotropes are there. So which we are considering either it may be a photosynthesis process or it may be by means of a aquatic organisms we are also using, sir. Then we are using a fuel which is having a biofuel term, because we are generating the fuel from the biomass which releases heat when combustions, and it can be stored, and it can be the energy can be transported. So the bioenergy which is used of the residue carbon in the biomass for the generation of heat, electricity, and also for the transportation of fuels. Now biorefinery. So biorefinery is nothing but a mimic of traditional petroleum refinery. So petroleum refinery process also, it's developed multiple products, as you know, that starting from gasoline, naphtha, and petrol. Then you are having wax, so LPG, kerosene. So there are so many products. Similarly, biorefinery also having so many products. So there must be an integrated biorefinery which can transform biomass into all different products, making the most of the raw materials which adapt to the marketing conditions. So if we are taking the biomass that will be producing into biorefineries, you can adopt any technologies, either it may be thermotechnologies, or it may be a biocatalytic technology or enzymatic technology, which will produce fuels, solvents, bulk chemicals, plastics, fibers, fine chemicals, and oils. As you know that fuels, we are generating ethanol and biodiesels, solvents, which will be acetone, butanol, and tetrahydrofuran. So bulk chemicals, we can produce sucrose, succinic acid. Plastics is a thermoplastics, and fibers, we are producing starch, cellulosic fibers, and fine chemicals, we are producing lactic acid esters, isosorbides, and oils, we are producing some bio oils and also corn oils, because when you are taking a biomass which will having a property of having a oil also, that oil can be extracted and you can deliver as a goods, that is a bio oil. Either most of the oils which we can use, that may be of bio oils also. So due to the competitions in the biorefineries, the space must strive to be more flexible, because you know these many products are available and which we can produce. Based on that, we will have more flexible systems, and also the value added products which we are getting is also high, and with the also we can make our bioeconomy succeed. So when you are comparing the products as we listed earlier, so we are producing bioalcohols, biodiesels, biogas, bioethers, aviation biofuels, and also we are producing advanced biofuels. So production are many forms of clean energy also. There is wide array of bio-based products, value-added waste biomasses, technical resolution of the waste treatment issues. We will find the biomass what we are taken as a waste, we are generating as a products, and also value-added products, and also steam and electricity. So we are resolving the technicals for waste management. So there is no competitions with the traditional uses of first generation biomass. Where then what are all the technologies? As I already mentioned, there are different technologies you can adopt. So what technology we can follow that based on the biomass we can characterize, either it may be a thermal conversion, or it may be a chemical conversion, or it may be a bio conversion. So when you are comparing the thermal conversion, that is combustion, gasification, and pyrolysis, which you can need high temperature operations. From that combustion, you can produce the steam. That steam will run the electricity. You can get the electricity from the by means of steam turbines and generators. So you can get thermal energy. At the same time, you can produce electrical energy also. So when you see that the biomass, whatever you can take, and you can take the combustion products. So the combustion gases which goes as a steam turbine, or it may be a gas turbine, or it may be MHD or ORC. You can produce the thermal energy. At the same time, you can produce electrical energy also. Similarly, the gasification process, the gases which can be used in the fuel cells, or the gases can be also used for the turbine and electricity generation. You can produce a thermal energy, or you can produce an electrical energy. Pyrolysis, it is an high temperature operations. Pyrolysis produced two different streams. One is in the form of gas, and another one is in the form of liquid oils. So the gases which can be used for biosynthesis, thereby you can go for production of bioethanol also. Similarly, the gases which goes to fuel cells, thereby you are producing carbon monoxide and H2. So you can produce a water gas there by means of that, you can produce the electrical energy. And also whatever the the pyrolysis product, which will be a solid residues, that will be a biocarbon that we can use as a fertilizers. So when you are going for a pyrolysis, you will have a different aspects of solid, liquid, gases. All these streams can be used for generation of thermal energy or electrical energy or any value-added products. When you come for an aerobic and anaerobic fermentations by bioprocess, either you produce electrical energy or you can produce the biomethane, which is having a biofuels. So anaerobic fermentations, without the presence of oxygen, the biomass which will be fermented, but you have to select the microbial strains where you can produce the biomethane. So the biogas which can be generated, which will be used for electrical energy purposes. Then aerobic fermentations, which we can easily maintain, because comparing to anaerobic fermentation, aerobic fermentation is easy and it is which will not produce any odor problems to environment. So aerobic fermentations which produce a bioethanol, which can be used as a biofuels. Anaerobic fermentation produce gases, but aerobic fermentations produce a slurry which will be used as an ethanol, and the slurry will be of high organic content, which we can use as a manure, and that is a organic fertilizers which we can improve the soil fertility. And the last one is pressing oxygenized extraction. The biomass what we are taken, which will be used for an extraction process, where we can take an oil from the biomass. That oil can be trans-esterified by means of esterification process and trans-esterification process, and with the aid of catalyst, thereby you will produce biofuels. The example biodiesel what we are adopting, so that by means of trans-esterification process. So trans-esterification process that we can discuss in detail in the upcoming session, in this session. So the products, the technology, either it may be a thermal or it may be a chemical or it may be a bio, the products which we can use as a thermal energy, electrical energy, or in the form of biofuels. So there is a flexible systems in the biorefinery compared to a petroleum refineries. So the biomass, whatever we are taken, so we are doing on our technology operations, pyrolysis, fermentation, combustion, gasification, extraction, fractionation, and separations. We are producing the chemicals in the form of energy, in the form of fuels, in the form of value-added materials or chemicals as a feedstocks and feeds to the animals, and also we are producing a value-added products. So entire life cycles from the cradle to grave concepts, we are performing whatever the resource which we are generating as a waste, we are doing a technology process and we are producing we are taking the valuable products, we are recover the valuable products, and we are maintaining our society, which will be of health and health. So now we are, some of the biorefineries we are seeing as examples, that is lignocellulosic biorefinery platforms. One platforms which will be from sugar, and another platforms we are taking as a thermochemical process. In the sugar platforms, you know that sugar cane processes, we are taking the biomass, cane sugar taken, and we are producing the sugar and the products which we can taken, and the bagasse which we can be taken, which we used as a fermentation process, which you can produce an ethanol and alcoholic industries. That bagasse, the fermented liquids, will be an anaerobic digesters that you can reduce the waste. At the same time, you can produce a biogas also. From the anaerobic digester, you can produce a biogas. At the same time, you can adopt the technologies for the generation of biofuels. So when you are comparing the lignocellulosic biorefineries, we are taking the biomass productions. That is the one. We have to grow it. We have to maintain the agricultural parameters, which is another factors. So biorefinery, which will not develop only the technology and the industries, and also we are promoting the agriculture. So the biomass is harvested and delivered to the biorefinery. That is the step one. And when you are, the biomass will be grown, it will be shreds and it will be cut, pre-treated. Heat treatment can be done by heat or chemical treatment, so that you can generate the cellulosic products by means of enzymatic actions or by means of mechanical actions. Then you go for hydrolysis. You know that anaerobic process, which also undergone a 3-step process: hydrolysis, acidogenesis, and methanogenesis, where you can produce methane. Like that, these processes will go for hydrolysis, fermentations, and biofuel processings, where you can optimize the usage of waste. At the same time, you are using the biomass into value-added products and also the bioenergy. When you are comparing the thermochemical platform, this is one platform where you are having a sugar platform, where you will take the lignocellulosic materials. Now, when we are comparing the thermochemical process, the feedstock, based on the feedstock logistics, how the feedstock may be moisture sensitive, or it may be it's a dry, wet. We have to check it out, what the type of feedstock. We have to perform the logistics on the feedstocks, and we have to process it, handle it, and we are using a lignin with separation of the processed cellulosic materials, lignin materials. That lignin, you can produce a biochemical conversions. There you can get the value-added products. Other materials which can be combusted, that is an high temperature operations. You can go for gasification. You can produce the gas, you can condition the gas, which that gas with the calorific value of that gas can be used as a combustion, for which we can produce a fuel gas, and you can use for industrial gases, which you can utilize that energy purposes. At the same time, these are all the things which you can having an environmental friendly. So now we are seeing the 4 generation of biofuels in the earlier slides. So the first generation, we can use corn, wheat, grains, sugarcane, or sugar beet or cassava. So that and all you are using in the first generation. Then the second generation, we are using the waste, biomass waste, forest biomass waste. As you know that forest, we are having a lot of biomass which will be generated. We are not doing a deforestation. We are taking the biomass from the forest that can be used for the production of electricity and energy, and also the industrial biomass wastes and the waste which can be generation. So you may ask the question, why we are deals with the generation of fuels, biofuels, why we are started from the first generation to the 4th generation. So we are using the first generation from the food. So the question maybe arises whether it's a food or fuel. So most of the peoples which we are in the planet are suffering from of food and not having they are died. Most of the cases are died because of hungriness. So that time we should not considering the fuel for the commodities. So the food is a major thing. So we are moving from that generation, first generation, because they are using a food resources. So now we are using the waste resources. We are not using the food. So the controversy which was raised as a food or fuel, now we found an alternative, that biomass or wastes, algae, that can be the source of fuels or energy. So we are having a different existing bio-based processing industries. So all the industries which we are having a generation of biomass. So some of the industries I have taken example of 5 industries today. The 5 industries are paper and pulp industry, where the biomass is generated. That biomass can be used for the fuel or energy productions. The second is sugarcane industries. As I already mentioned, that sugar industries is a major source of generation of biomass. And the third one is algae. From the algae, how it will be generating the biomass. Then enzymatic industries and cotton industries. So the paper and pulp industries. So you know that papers and pulps we can take from the wood materials or trees. So which the trees are the trees which contains 15 to 25% of lignin and 23 to 32% of hemicellulose and 38 to 50% of cellulosic contents. So the wood materials will be taken and it will be shipped. So wood chips are made. That wood chips will be undergone hydrolysis. So thereby you can segregate the cellulosic materials and hemicellulosic materials. The hemicellulosic materials will be undergone the fermentation process, and you can produce the lactic acid and ethanol as a value-added products. Then the cellulosic lignin materials will be cooked, and you can separate the lignin from the cellulosic lignin. So first one, hemicellulose, which can be separated by means of washing itself, hydrolysis itself, because if that will be water soluble, you can separate the hemicellulose. The cellulosic and lignin, you have to cook it, you have to make alkaline adjustments, and you can use for the separation of lignin. That lignin will be separated. This cellulosic materials can be used as used in the furnace or in the boilers, where you can generate electricity and heat. This lignin can be used for production of the value-added chemicals like phenolic resins, carbon fibers, toluene, benzenes, adhesives, and solvents, and also you can produce paper. So when you are producing a paper and pulp industries, you are producing the value-added chemicals, you are producing energy, you are producing lignin. From lignin, you can producing chemicals. At the same time, you are having a major source which you have desired products is paper and pulp. Either you can take the biomass from the boiler, also you can use it for the production of biofuels. Then the second one, as we discussed earlier, that is nothing but a sugarcane industry, where beverages industry, breweries and beverage industry. So the sugarcane, canned sugars, which will be taken after the taken of the valuable products like sugars and jaggeries we are preparing, what we are using in the day-to-day life, that we can take in, whatever the extracted bagasse, that will be given to the processing, for the processing, where brewery industries, where you can take the molasses. From the molasses you can ferment it and you can produce the alcohols, and you can take the final fermented liquids that you undergo an anaerobic process, anaerobic digestions, you can produce biogas. So this is a second industry where we are seeing a beverage processing industries and brewery industries. Then the third one, as you know, that enzyme production industries, which you can use in the food industry or food processing industries. So that the enzymes which can generate, so the enzyme generations which requires media. So after that, it will be also a fermentation one. So major inoculations and fermentation broth, you can take it, either you can go for submerged fermentation or solid fermentation. You can generate the cell separations and you can produce the biomass. That biomass you can compost and you can produce manures and that. The fermentation liquids you can take it, that molasses you can take it, that you undergo the technologies of producing a biogas, or you can produce a manure, or you can produce a animal feed. So when you are seeing about the enzyme production industries, you can having a various scopes of producing biomass or manure or biogas, or it may be a compost, or it may be an animal feed. So anaerobic digestion process, as we are taken various solid wastes. So the solid waste generation, what we are developing today is in the enormous quantity. So that solid waste, organic solid waste, that can be taken and it will be used for the generation of biogas, which is having a methane and carbon dioxide. So either you can take from the food waste, or it may be from animal waste, or it may be organic waste from trees, leaves, whatever we are using, that we can having an anaerobic digestion. So that produce the biogas, which you can use energy, and whatever the digested liquids or solid materials will be the digestate, that can be taken and you can produce the pyrolysis process. Thereby you can produce the syngas also, that also you can use as a generation of energy. That pyrolysis oil and pyrolysis solid materials, the whatever you are producing, the digestate, from the digestate you are producing the bio oil, that can be also used. At the same time, the pyrochar, that can be used as an adsorbent, or you can use as a fertilizers. These are all organic fertilizers. So the last industry which we can see is an algae processing industries. We are doing algae, we are cultivating the algae. One purpose of algae is you can use this algae for phytoremediation things, whatever we are taking the waste materials, waste treatment process, we can go for phytoremediation by means of algae production. That algae you can take, and you take the extraction process, you can take the oil, algal oil also you can produce, or otherwise you can go for enzymatic liquefaction process. You can produce the fermentation, and by fermentation you can produce a bio oils, and the bio digestate also you can take it. So the technologies which you can use for the algae processing industries, either you can produce extraction, thereby you can produce the biofuels, or you can go for enzymatic liquefaction process, thereby you can follow the fermentation process, which you can already follow for sugarcane industries. So these are all the 5 industries which we can look into it. One is paper and pulp. The second one is sugarcane industry, that is a beverage industry, brewery industries. And the third one is an enzymatic production industry. Fourth one, what we are discussing as the anaerobic digestions from the waste we are producing. And the fifth industry is an algae processing industry. When we are comparing the over 5 industry, the paper and pulp industry, beverage industry, and the enzymatic industry will generate biomass. And anaerobic digestion and the final algae sequestrations or algae treatment process, which produce a waste management. So when we are integrating these things using of biomass and using of the waste, that is generating the integrated biorefining process. That comparing to petroleum refinery process, biorefinery process having over advantages. When you are comparing the biorefinery process, integrated biorefining process are comparatively more better than biorefineries, which we can produce a biomass, we can produce bio oil, we can produce oil value added chemicals, we can produce bioorganic fertilizers. So the scope for generating this integrated biorefining process will be more. As you know that the paper and pulp industries, which produce the cellulosic materials and lignin contents, from the lignin you can generate various value added chemicals. So seaweeds will produce, nowadays the research is going on from the seaweeds. From the seaweeds we are taken an oil lipid content, and that you can use the seaweeds for the production of bioethanol. That the emerging technologies, we can use the seaweeds. So at the same time, we are having a seaweed processing industries where the products are similarly what we are discussed in these 5 industries: biogas, bioethanol, biodiesels, and bio oil or biochars. So you have to adopt the technology in such a way that which will be suited for your feedstocks. Similarly, agave industrial process, where we are having a agave, which you can identify which type of feedstock and which technology you have to adopt. You have to optimize in such a way that which land suitable for that cultivation of the chemicals. If that the products will be cultivated more, for example, if the land is having a sugarcane land, then you can have a planning of sugar processing industries. And if you are having an agave, you can go for oil extraction and you can produce various value added products. Similarly, which beverage and which type of feedstocks based on the land, suitability of the land, availability of the technologies, and the major cultivations. When you are plant layout, you have to select the soil characteristic, geometrical collections, and you can produce which type of feedstocks and which technology you can adopt. So as we discussed the sugarcane biorefinery, so when you are integrating that, you can having a agricultural land for producing sugarcane. That sugarcane you can take in for sugar generation or products of sugars, which we can use for the day-to-day life. And from that you can produce the breweries from the sugarcane molasses. Then the molasses you can go for anaerobic digestion. You can produce the biogas or bio oil or organic manures. So when you are seeing that integrated biorefining process, starting from the agricultural, you are having a technology, you are producing value-added chemicals, bioenergy, and bio oils. Similarly, timber processing industries, where you can take the biomass like sawdust, forest debris, and wood scraps, that also you can produce for biofuel or bioorganic generations. So the food processing, what we are generating, we should not waste food. That is our main motto. Even though some food processing industries, that shells that will be generated as the waste that can be discarded, that food waste in the reference, which can be not edible, not edible. So the food waste processing industries, that mushroom waste, shells, crab shells, that can be used for the generation of cellulosic materials. Thereby you will produce the biomass and biofuels. Similarly, the cotton processing industries, we are using cottons for the generation of textile industries, the cotton shells and the waste which we are generating, cotton hulls, cotton seeds, that can be used as a biomass for the generation of biofuels. Tuber processing industries, as a same that cassava. So you are having a sweet potato peels, that you can generate chips. Whatever edible part, you can take it. Then from that, whatever it's waste, that processing biomass you can take. So we are not generating only the, we are not using the food resources, because food is required for each and every person, and it will be the fundamental rights. So the wastes which can be generated from the food processing industries or food industries, that can be utilized as a waste, our source. So fruits and vegetable industries, also the fruit shells, scraps, fruit peels, that you can use as a biomass generations. And date seeds, that also you can take as a biomass generations. Most of the abroad countries, UAE countries, will having a biomass waste generated from the dates that can be used. Similarly, the grains, after processing, so you are having so many molasses which will be generated, the washed liquids which also contain starch content that can be used for the biomass source. The various biodiesels productions are there, which you can having a various natural resources that can be used for the generation of biodiesels. A quick go through, we can how you can produce the biodiesels. So biodiesels we are used from plant resources. Also, we are producing biodiesels in Satyabama. We are producing a biodiesels by using a pilot plant, which we can use for the running of buses in blending with the petroleum refinery diesels. So we are proud that we are operating the buses in blending with biodiesels, and Satyabama takes a major role in considering the sustainability development goals. So by using the used cooking oil, we can produce the biodiesels by means of trans-esterification. You know, trans-esterification, by using a OH catalyst, you can convert the fatty acids into a glycerol and diesels. So you are having a various chance of catalysts. You can acid catalyst, either you can adopt enzymatic processes or heterogeneous processes or in situ trans-esterification. So we are producing biodiesels from plant oils. That algae oil, we are taking the algae, we are extracting the algae, taking the algal oils, and we can produce the biodiesel. At the same time, we are use the cooking oil, waste cooking oil. Once it will be cooked, it can't be used further. That time, that waste cooking oil also you can use as a source of biodiesels, and that triglycerides along with methanol in the presence of NaOH catalyst and KOH catalyst. Nowadays, the research is going on various generation of catalyst, nano catalyst, like that we are having a heterogeneous catalyst. Comparing to homogeneous catalyst, heterogeneous catalyst will have an advantage of reusability. So that we are applying the sustainability concept in also in the catalyst generations. So we are producing the fatty esters and the glycerin. So glycerin is a value-added products, and the fatty esters are the biodiesels, which you can purify it and you can produce for the utilization of biodiesels. So we are having a biodiesels. We are taking the biodiesel trans-esterification, then extraction unit for the separation of glycerol and biodiesel. So now the take-home message from this today's session of day 5, we are using our natural types, various types of fossil fuels, and we are processing various products, and there is a demand of fuel. You know that the commodity, the basic needs are increasing day by day. So the fuel demand is increasing. So that should not affect the environment. So we are having a biorefinery concepts, and also how it is different from the petroleum refinery, and what are all the advantages of the integrated biorefining process, how we are producing biodiesels, and what are all the bioproducts, bio oil, biomass, bioenergy, biofuel. So that and all we are making a concept of sustainability, and to achieve the sustainability goals, and what are all the feedstocks which are available for integrated biorefining process. So this is the take-home message from this today's sessions. We are taking a oath to maintain our environment, which is for sustainable environment, and we can adopt these concepts to maintain our environment, a green environment, a green planet. Thank you. Karthikeyan sir. So once again, I thanks to Iei Kancheepuram local centers for giving a wonderful opportunity for arranging this program. At the same time, participation in the 100 hours Iei Tnsc Techno Carnival, Asia Book of Records attempt. I thank all the speakers, Dr. E. Annadevi, Dr. D. Prabhu, Dr. D. Venkatesan, for contributing their knowledge in the sustainability, in maintaining the sustainable environment, sustainable energy, and sustainable design. And I also thank to our management for providing us a wonderful opportunity. At the same time, I thank Dr. S. Karthikeyan, Program Coordinator. I thank Chairman, Iei KLC, Dr. Ilango sir, for providing this opportunity to the Satyabama Institute of Science and Technology, Department of Chemical Engineering. I thank Dr. G. Shanmugasundar, Honorary Secretary, IEI KLC, also for guiding us throughout this program. Thank you. Thank you. Last but not the least, I thank all the participants for the patient listen of this day 5 program from 9 a.m. to 12 noon. So I thank each and everyone for present in the day 5 and witnessing this Asia Book of Records. Thank you. Karthikeyan sir. Thank you all. Ma'am, Johnny ma'am. Ma'am, Iei Tnsc ma'am, host ma'am, host sir. Okay, thank you, participants. Thank you for your presence. Thank you. You can leave. Thank you all. Okay, thank you all. You can leave now. Surya, Rino, thank you, Mr. Surya, Rino. Thank you. You can leave. Huh? Okay.